Cool. So we have been studying linked list for 3 lectures now. I mean, this is the third lecture, right? So today we are also going to look into circular linked list and doubly linked list. These are nothing but just a variety of linked list. And if you carefully see, there is nothing that is new. That also requires the same manipulation of links. है ना? Node is the same only, and just the concept is different in a very small way, right? So before we go there, let's just solve this one question for warm up. Delete node without head pointer. This one, right? This is one question. Okay, so this question, it's not actually, its power is not in the concepts of linked list. It's just that this question is a very tricky one, very easy, but I just like it because of its simple nature and the thought behind it. So let's read the problem statement. Okay, delete node in a linked list. Okay, fair enough. There is a singly linked list head, and we want to delete a node in it. Basically, the node is given to you as node, and you want to delete that node. You are given yeah, you are given the node to be deleted. Okay, you will not be given access to the head. Okay, you will not be given access to the head. You will just be given access to the node that you want to delete. All the values of linked list are unique. Okay, and it is guaranteed that the given node is not the last node of the linked list. Just, I mean, at this point you would not be able to appreciate what this particular line means, but after I tell you the solution, you will realize why this line is very important. The given node is not the last node of the linked list. Okay, that's the important part. Now before I directly jump to tell you about this particular question, let me just get some ideas from you on how we can delete a node in a linked list, in a normal linked list, right? Let me also code it in IntelliJ, right? So let it just load there. Okay, we've reached here. Anyways, right. Let me just minimize it for now. So let me just get some ideas on how we will delete a node in a linked list normally, right? So this is how your linked list looks like. Something like this, right? So maybe 3, 8, 7. This is your linked list, and I ask you to delete this particular node. Okay, I ask you to delete this particular node, right? Now, ultimately, as human beings tell me, like, do not worry about linked list or anything, how you will do it. By observation, do you guys agree that this is how the linked list should look like after deletion? That's it, right? This is how the linked list should look like. Let me just enable chat for a minute. Okay, only answer for the questions that I'm asking. If you have any other doubts, we can take that up after I'm done discussing this, right? So, right, Zoom link I have shared. Let me just share that once again. Okay. Anyways, so I forgot to turn on my camera. Okay. Okay. Yeah. So this is how it should look like after deletion, right? I don't think any of you have a doubt in that portion. So if you carefully see what's happening in this particular case, only one thing is happening. You are taking a link from the previous node of the node to be deleted. This is the node to be deleted. This is the previous node. So what you are actually doing is you are making its next pointer point to the next node of the deleted node. Basically, you want to delete it. So having this link does not make any sense anymore. So you want to establish a link like this, right? This is what you want to establish. So let's say the node to be deleted is the current node, and the node which is previous to it is the previous node. So what you actually want is previous dot next is equal to current dot next. Do you agree with this? So basically, as soon as you write this line, let me tell you what will happen. Okay. So yeah, what you want is you write previous dot next is equal to current dot next. So basically this link will go away, and where will it point now? Current dot next. This is the current node. So current dot next is this node. So a pointer, or you can say a link like this will be established, and this link will be gone. That is all you need to do. Okay, that is all you need to do. So basically, before you reach this particular position, what's more important is how you are coming and arriving at the current and the previous node. That's the only thing that's important. Other than that, the deletion logic is just one line. Is just one line thing that you need to worry about. Okay, are you all clear with it? Previous dot next is equal to previous dot next dot next. Yeah, yeah, Daniel, why not? You are correct. Current dot next is equal to null करना होगा क्या? So yeah, so people also do this thing. They also want to remove this particular link, right? So that has something to do with garbage collection that I'm not going to go into depth of. But the basic idea is, for this node to be actually deleted from Java's memory, it should not have any form of links with any particular node. Okay, so people also delete this particular link, right? So all you need to do is current dot next is equal to null, right? So this is also a line that people write, but if you carefully see, this won't matter to us. Writing this line will not matter to us, because anyways, when you will traverse the linked list, you will come to 3. If you do dot next, you will come to 7. If you do dot next, you will traverse the linked list further, right? But people prefer removing this link as well, so that's what we will also follow, right? So current dot next is equal to null, and this link will also go away, right? So in the end, what we will have is, we will have this node sitting alone, right? And this link established like this. So that's all we wanted, right? So the main job reduces to finding the correct current and previous. Current is the node you want to delete, and previous is the node which is previous to the node to be deleted, right? After we arrive at current and previous, is the logic for question clear to you? Kamar, I told right, how previous dot next is equal to current dot next. So see, do you realize that we want to have something like this ultimately, because we want to delete 8, right? We want 8 to be deleted. Earlier the picture is like this, right? Now you want a link from 3 to 7, so you want a link like this, right? 3 is what? The previous node of the node to be deleted, so I have marked it as previous. 8 is the current node. So what I'm doing is previous dot next. So basically this particular link should store what value? The value of this reference. Previous dot next is equal to current dot next, right? Current dot next is what? This node. Previous dot next is what? This variable where you want to store the value. So you will store the reference of this node. This will go away, right? So your deletion is done. Now for the sake of completeness, some people also remove this particular link. How will you do that? Current dot next is equal to null, right? Node dot data is equal to node dot, why don't we are not concerned about the data, right? Okay, Mohit, I think you are proposing the solution for the question that we're discussing. Don't worry, you are right only, but yeah, can we do previous dot next is equal to yes, Rahul, why not? We need to initialize previous dot next, current dot next. Initialize nahi, better word would be, we need to assign them correct values, right? Guys, please don't give the solution for this particular question. Okay, let's discuss the general delete first, and then we can go and solve that one as well. So now, is it clear to all of you that we will require the help of the previous node to delete the actual node that we want to delete, right? Is that portion clear to you? And if we take the address of next node and ignore 8, what will happen to node 8? So the thing is, it will still have a link to this particular node, so it will not actually be removed from the memory. But to remove it actually from the memory, we want to remove all the ties that it has with any particular node. So that's the only reason we do that, right? This is the brute force, this is the optimize. It's pretty straightforward, right? So for deletion, your time complexity will always have to be O of n only. because you will have to come to the point where you want to delete your node, right? So there is no optimal approach or anything for this, right? No, so Tausif, I told you, right? It's a better practice, right? For from the perspective of garbage collection, that will actually lead to the deletion of that node, but it's not necessary, right? Because जब आप उसको traverse करोगे, so this link is gone, so we will never reach 8 anyways, right? Now let me just close the chat for you guys. What if we want to point multiple nodes at one node? Will garbage collector cause any problem? Multiple nodes are pointing to one node, so yeah, we don't want I think I don't have answer to this particular question at this point, right? So and it's not clear to me what you want to do, so maybe we can discuss it separately as well. Are there any operations in which array is better than linked list? Yeah, so Tushar, accessing, right? Accessing a particular element is an O1 operation in array, where you just write array of 0, array of 4. Let me just put my phone on silent, right? So in that way, array is the best, right, for accessing. It's a O1 operation. Here, if you want, if I ask you to access the last element, that's a O of n operation, right? You will have to traverse the whole linked list and then you will reach the end of the linked list, right? So in that way, array is better. So let's try and code about it. And before we go there, before we go about coding, see, I took a generic case where I said there is going to be a previous node for the node that we want to delete. But let's take some edge cases and see if our if our calculation is still valid there, right? So let me tell you what I want to say. So what if I want to delete the head node itself? So this is the picture. Let's say 3, 4, 8, and I want to delete this node only. In this case, previous is null. So you can't say previous dot next is equal to current dot next, whatever. All you want to do is you want to move your head from here to here. That's as simple as it's as simple as that, right? Removal of head. So that is what you will do as well, right? That's exactly what you will do. So head you will move to head dot next, right? So that's something that you will handle separately, because in this case your other logic will not work. Previous dot next is equal to current dot next, all that stuff, right? Because there is no previous node that head has. So now let's tackle the delete function. Okay, so let's see what our delete function will do. So we are making it simple. So we are not passing the reference of node or anything. We are passing the value that has that value. Okay, right? So delete node, which node that has this value. Okay, so let's first reach this particular node. Okay, how will we do that? Right, while temp is not equal to null, temp dot val is not equal to val, right? So basically, as soon as temp's value becomes, or let's do it this way, right? It's actually the current node that we want to search for, and the previous will initially point to null. So let's do it this way, right? So it's not temp. I'll explain you what I mean. Just let me complete this. Okay, so what I want to do here is, I have a previous node, I have a current node. What I want to do is, I want to traverse this particular linked list. Guys, just give me 1 second, my cook has come. Yeah, sorry for the disturbance, guys. What I was saying was, I want to find the node that I want to delete. Okay, that is what I'm naming as the current node, right? So that's what I'm putting the condition as. Yeah, so this is also a possibility, right? That my current reaches the end of the linked list. That's also a possibility. So that should not happen, and current's value should not be equal to the value that I am passing. Why am I saying not equal to? Where I actually want to, look for the node that has value equal to that value. I am saying not equal to because it will keep on searching till the value is not equal to this particular value. As soon as the value becomes equal to the target node or the target value to be deleted, I will stop there. So do you realize after this while loop, my current will point to the node that has val value. This is my point here, right? So what you will do here is, and before you do this, so basically, are you seeing this? We are just preparing the previous and current pointers for the next iteration. So as of now, previous is null because we have just started with the we have just started with the calculation. So what you are doing here is previous is equal to current, because for the next time previous will come one step ahead, right? Previous will come at the spot of current, and current is actually becoming current dot next. So we are just moving these two pointers ahead. Till the time current is not null, you should not exit the linked list, and current.val is not equal to val. So do you realize that after this particular while loop, your current will point to the node that has val value? This you can tell me in the chat, right? I have opened it. Okay. Also, Anmol, go ahead. Yeah, Anmol.
सर इसमें अगर हमें लास्ट नोड अगर गिवन हो, अगर ऐसा केस हो तो उसमें ये हैंडल हो जाएगा ना?
हो जाएगा आपको डायग्राम करके दिखाता हूँ, है ना? ओके, can we write pre is equal to pre dot next? So Durga, why I did not write it that way, there's only one reason. Okay, initially na previous is equal to null, so just from that perspective I'm not taking that chance. Previous is equal to previous dot next, right? If you carefully see, previous is equal to previous dot next or previous is equal to current, it's just one and the same thing, right? But if I do previous is equal to previous dot next, at the first iteration I will get a null pointer exception. Okay, why are we taking current dot val not equal to val? So guys, what I want to do is, I want to stop my calculation when I reach the node that has this value, right? So basically I want to stop when the value is equal, but here I am writing the condition for which I want to move to the next node. I want to move to the next node if my current node does not have the value that I want to delete. Do you understand? If it does not have the value that I want to delete, I will go ahead and search for the next node. Search for the same value in the next node, right? So that's what I'm doing. I am moving forward till the value is not equal. As soon as the value becomes equal, I will go out of the while loop. So basically, when I get out of the while loop, my current is going to point to the node that has our target value, right? So if we have duplicate values, that's a different basically scenario, Bharat. In that case, the question will tell you delete the first occurrence or delete the last occurrence. In that way it will happen, right? So don't worry about that. Anyways, so yeah, here we are. Now there are two cases that we talked about. First is if you want to delete the head, or you can say if head is the node to be deleted, right? So in that case, what you will do is, how will you determine that that is the case? Head node is the one to be deleted. I'll tell you how. Okay, at the first iteration only, what you will say is current dot val is actually equal to val, because at the starting current is pointing to head only, right? So at the first iteration only you will get out. So previous is still null. Do you realize that? Previous is still null. So what you will do here is, if previous is equal to null, what you will do is head is equal to head dot next. Okay, and let's, in the beginning only, let's just remove this particular condition. If head, we are not taking that case at all, right? So basically, after when we are at this point, after line 40, we are sure that at least something is there in our linked list. Our linked list is not empty, right? So if head node is the one that you want to delete, you can say head is equal to head dot next. That's all. Another way of checking this is, and this is pretty straightforward, the next thing that I'm going to tell you, you can write this statement as well, right? If the node that you want to delete is the head node only, do this, right? So this is also something you can write, but I wanted you to, I'm just doing this for the sole reason of making you understand each and every iteration thoroughly, properly, so that this particular iteration, thoroughly. That's, I'm just reusing the word. So this iteration should be very much clear to you. What is happening in each step? What is happening in the first step? Right? What is happening in the last step? How is it functioning? So from that perspective, I said if previous is still null, that means you stopped, or you can say you exited the while loop just as you entered it, right? Because previous is still null, that means head node is the one to be deleted, right? Else you want to delete a middle node, what you will do is previous dot next is equal to current dot next, right? And current dot next is equal to null, right? You can also do current is equal to null. All the things you can do. So basically, that node that you have, no reference is pointing to that node, you are not taking any reference out of that node, that is completely done, right? So these are just additional steps. This is the main step. This is the main linking step that you want to do. Okay, is there anything else left now? No. So we are coming here, we are making our current and previous pointers point correctly. If I want to delete the head node, I will do this. Else, if I want to delete I'm just calling it non-head node, right? So let's take a demo of this function, right? Let's see if it's working correctly or not. So going back to main, let's insert one more value, 3, 5, 8, 9. Okay, and let's try and delete each of these values. Let's see how it's working, right? L1 dot delete. So first I'm deleting 3. Let's see whether I'm getting 5, 8, 9 printed or not. Okay, let's see. Okay, I have coded print reverse. Anyways, 985 instead of 589, I got 985 because I wrote print reverse here. But anyways, print linked list. Let me call this function. So I think you know that we will get 589 printed like this. 589, right? Now if I want to delete the value 5, what will happen? I should get 389, right? 389. Similarly, you can delete 8 also. 8 is same as 5. Let me delete the last node, that is 9. Okay, I should get 358. 358, just like that, right? So are you all clear with the logic of delete function now? Let me allow you to chat. Right? Okay. Cool then. Duplicate value may, in that case, you will you will have specific instruction which particular occurrence you want to delete, or they might just send you the node that they want you to delete, right? So that's also one thing. Yeah, this is module 2. Yeah. If value is not present. Okay, if value is not present, very good, right? So I actually took that case, right? What will happen if the value is not present? Do you agree with this? If you traverse the whole linked list, your current will become what? It will become null. So if current becomes null, that means you have traversed the whole linked list and this condition was always true, or there was no node which had the value val. Okay, so basically it's like saying delete something that does not exist in the first place. So that's something that doesn't make sense. So let's write a condition for that as well. If current is equal to null, sorry, or you can say let's write like this. Val is not present Okay, you can write a message like this. So let's do that also. Right, let's go to the main function, delete something that's not even there. So write 15 and let's see what we get. We will get the correct linked list, that is 3589, and we will also get that print message, right? Sorry, what happened? 15 is not present in the linked list. Exception in the thread. Null pointer exception. Okay, it's good that we got a null pointer exception, but where are we getting it? Delete node, right? Delete node. Okay, sorry. After having done this, we also have to return, because basically our current is null, right? So all the other operations that we plan to do, right? Just say, see this particular operation, this is relying on the fact that you have found your current node, right? The node that is to be deleted. So we are doing some operations on current. So current.next, all that stuff we are doing. That's not really relevant now. So we will just return from this point. Not an issue. We will not get the error anymore. Right? 3589. 15 is not present in the linked list. 3589. Right? So your linked list remains intact. Now, the point is, do you realize at this point how important the previous node is if we want to delete any particular node? Because from the previous node only we want to establish a connection to the next node of the current node, right? So is that idea clear to you? Current.val is not equal to val. Didn't understand this. Can you explain this, please? I already explained it twice, but I'll go again. Yeah, SK. Okay, you lowered your hand. Please use online GDB. That I will not use, okay? Because this request I have received earlier also, that doesn't make any sense. Like the choice of ID, if you are getting confused there only, it's what's the point of asking me to change the ID? The code is still the same, right? I don't understand this request. You can say repeat, you can ask me to conduct extra classes, whatever. You can ask me to repeat any particular concept, but this is the same code that I'm going to do, even if I choose online GDB. It's just that I will take some time to get acquainted there, and it will again lead to wastage of time. That's something I'm not going to do at all. After unlinking, what happens to the node which was unlinked? So Jyoti, there is a automatic, you can say, mechanism in Java for garbage collection, right? So you can read more about it, and there will come a time that then when we only will discuss it in our class. So either wait for that or you can read about it. So no issues there. If we want to delete multiple nodes, call the delete function multiple times, right? That's a easy answer. What if we want to delete the node at a particular index? Go there and delete it. Vipul, it's similar to what we are doing here, right? So it's like I'm giving you a value and you are reaching that particular value and you are assigning the previous and current correctly. Now you are saying I want to delete the node at index 6, let's just say. So what you will do is you will run your while loop 6 times. That's even easier now, right? So that way you can go to that particular node. Just rest all the things will remain the same, right? So that's something I would ask you to do. If you have understood this, you can do it very easily, right? So yeah, Shubham, go ahead.
या सर सेम प्रॉब्लम कि पर्टिकुलर इंडेक्स पर रहेगा तो क्या करना, आपने वो अभी एक्सप्लेन किया है इसको।
समझा?
यस सर, यस।
हाँ, बिल्कुल ऐसा है जो अपन कर रहे हैं।
जैसे
Exactly.
सिंपल फोर लूप से भी कर सकते हैं सर, k-1
बिल्कुल
तक
बिल्कुल
पहुंचना।
अपन, when we know the number of times we want to do something, we use for loop only, I plus plus or a thing, right?
यस सर।
Yeah, you can do it. All the elite questions you can solve from this point on,
यस
right? It's just a manipulation of this thing that we are doing, right?
यस
But
सर।
to do any, be it delete or any other operation on linked list, be comfortable with what we are doing in the class. Some of you, I'm sure, okay, some of you would not be getting the whole sense of this delete function or all the functions that I'm writing. You would just be trying to absorb it or mug it up. Don't do that, okay? If you are finding the class fast, that's also a possibility, right? Because you guys are doing linked list for the first time. If let's say you think that the class is fast, go to your place, or you're already at your place. After the class, make sure that you are taking these codes and doing a dry run yourself, okay? Because linked list is all about dry run, okay? It's also about me doing dry runs in the class, and it's also about you doing dry runs after the class, right? Because no matter how much times I explain a particular concept, linked list is something that it doesn't have much theory. Do you see any theory that I tell you? Deleting a node of a linked list is also a kind of question only. The only theory that I told you was on day one. This is how the node class will be made, and this is how your linked list class is there. Inside the linked list class, we have just been making new and new functions. So there is no theory in this topic, right? It's just a matter of practice. I learned it through practice, and I like this concept very much. You will also learn it through practice only. So make sure you do that, okay? And rest, we are here only, right? So yeah, SK, go ahead.
हेलो सर। सर
Hello.
क्वेश्चन को लॉजिक जो है अंडरस्टैंडिंग तो समझ में आ रहा है सर, बट इसको कैसे इम्प्लीमेंट करते, कौन सी क्लास कहाँ से आ रही है, ये समझ में नहीं आ रहा, क्योंकि आप सेम कोड ही डेली एग्जिस्ट करा देते हो। अगर न्यू कोड जैसे डेली अगर नया कोड कैसे इनपुट लेते हैं, कैसे आउटपुट देना है, ये समझ में नहीं आ रहा। कोई कैसे क्लास को एग्जिस्ट करना है दूसरी क्लास से।
एक काम करते हैं, I'm muting you because echo hota hai. So there is this question that I have planned, right? Insertion in a circular linked list. So why I do that? Let's say I'm reusing the node class, I'm reusing the linked list class, because it doesn't make sense to make it again and again. But your concern is also valid, that you are getting confused because we are reusing the same code. So I'll code this one from the scratch. Okay, node बना लेंगे, linked list बना लेंगे. We will do it in that fashion, है ना? Also रही बात using another class in this class. So just be comfortable with one idea, only one idea. That is, linked list is one entity which is made up of nodes, right? So anytime you are inserting to a linked list, you will always do this: node n is equal to new node, right? And you will make a link from the previously existing node to the current node, right? And what is a linked list? Linked list is the whole entity. But why do we only have, so do you see this? I think some of you would also get confused in this idea. Linked list does not have a variable of its own, right? It does not have any space allocator or a block of memory that would say, okay, I have to store 20 nodes here. It just has one sweet and simple variable called as head. Why does that happen? Because for a linked list, there is only one thing that it needs to identify all of its nodes, right? That is the head. Using its head, it can go and traverse all the nodes. So these are the basic things about linked list, right? And we are just using two classes, right? Linked list class to represent our functions, and node class. And what's more important in this particular discussion is the node class, because ultimately what we are doing is just the linking only, which is all done from the properties of the node only. जैसे next को मैं declare कर रहा हूँ, I am making it point to a particular node. All these operations that I am doing are just using the node class only, right? Making a linked list class, this is just to kind of replicate the concepts of OOP. This making of this particular class is not very much important, right? So just to give a general idea, I'm making this class, right? Otherwise you can do it without this class as well. Anyways, जो अगला question है that I will solve from the scratch, zero code I will take from the previous reference. Okay. Having said that, yeah, I'll just take this last doubt and then I'll have to get back to track. Okay. Yeah. Prashant. Okay, Vamsi. Prashant, I'll come back to you. Yeah, Vamsi, go ahead.
No, sir.
Yeah, what's it out?
In that case, what if the node is not present?
Okay, what if the node is not present? So do you realize that when the node is not present, what will happen? We will have traversed the whole linked list, but we will never get out, right? Because that condition will always be true. This condition that we have, current's value not equal to the value. This will always be true, right? So we will always keep moving to the next node in hope for finding this value. Do you agree? है ना?
Okay.
So ultimately what will happen? You are moving, you are moving, you are moving. एक point पे, at some point, you will reach null, right?
Okay.
What does that mean? You have seen the whole linked list, but not found a single node that has this value, right? So basically,
Okay.
after having traversed this while loop, where does the while loop stop? Either current becomes null or current points to the node which has this value. So if current becomes null, that means you have traversed the whole linked list, but you have not gotten that particular value. So in this case, you are just printing that this particular value is not present in the linked list, and you are just returning from there, right? Because current is null, and all the operations are doing current.next. So I told you yesterday also, you can't do a dot next or dot val on something that is null in itself, right?
Okay. Understood.
So that's how we are handling the data does not exist wala case. Okay. So let me also ask from Prashant, and then I will just move ahead. Yeah, Prashant.
Sir.
Yeah.
Hello, sir.
Yeah, go ahead.
Hello.
Yeah, I
Sir,
can
how
hear.
will we get access to the head node, sir, without pausing the head node, sir, in the function?
Actually, there is a disturbance in your noise, so I can't understand what you are saying. Maybe you can type it up, and I will read your message next. Okay. Cool then. Okay. So now you are clear with the idea of delete function. Let's go to the question that we have here, right? This question is just for warm up. So let's see what we have here. You are just given the node that you want to delete. So it's like you are just given the current, right? You are only given the current. Now what you want to do is you want to delete this particular node. Can you do it? In short, the answer is no. But if we try to apply a trick, there is one thing that we can do. Okay. So what these guys have done, 4519, let's take this example, right? 4 5 1 9. Okay, this is what you have here, and they want you to delete 5. They have only given you the reference of this particular node, nothing about this previous node or anything, right? So in short, the answer is you cannot delete this particular node. Okay, you just cannot delete this particular node. But the trick that they have used here is, see, ultimately you want a linked list that looks like this, right? That looks like this. So what they have done is a trick that they have applied. They know that you can't delete the current node if you don't have access to the previous node. So what they have done very cleverly is, I mean, by they I mean the person who thought about the solution or who made the question in the first place, moved the value of 1 to this 5, right? It's very safe to do it because this value 5, we anyways do not want anymore, right? We don't want the value 5 again. So move the value of 1 to 5. So this particular node will look like this. It will contain the value 1. Instead of deleting this node, now you delete this node. Okay, now you delete this node because you have access to this. This was actually your current, and now that you are deleting this node, you have access to the previous node also, right? let me call it node only to avoid confusion. This was the node that was given to you by question. But by trick, what you are doing is you are copying the value of this node to the previous one. And now what you are doing is you are deleting this node instead of deleting this node. And what you will cleverly do is, so something like this, what you have done here is node.val is equal to node.next.val. Then at this point, what you want to do is you want to establish a link like this. So node.next is equal to node.next. Okay, that is all. That is all what you will do. Okay, it's the only thing that you need to do here, right? Is this thing clear? First thing what you did was, this was the node that you originally wanted to delete, right? So instead of deleting this, what you did was, because you don't have any other option, you copied the value from here to this node. After that, what you did, I have started recording. After this, what you did was, this node can be retained now and this node can be deleted, because it's like the value has already been stored somewhere, right? It's stored safely. So instead of deleting this, which you can't delete, you are aiming to delete this because you have the access of previous node here. So to delete this, what you are doing is node.next, the next for this one is equal to node.next. So the next for this particular node will now point to 9, right? So the picture will look something like this. Okay, there will be a new connection established and it will look something like this. So that's what will happen, right? So coding wise, it's nothing. So what you will do is node.val is equal to node.next. .val, because you don't need the node.val, whatever was originally residing there, you don't need that anymore. So you can just directly copy the value of next node to this current node. And what you will do next is node.next is equal to node.next, right? That's all you will do. And if we try to submit it, right, it worked. There are only some questions in which we can directly hit the submit button. A question that has 2 lines of code is definitely one such question, right? So are you all clear with this approach now? Let me allow you to chat. Okay, one is clear. Anmol, unmute yourself. Okay, before I go to Anmol, let me go to Sam. Yeah, go ahead. What if we want to delete the last element? So Syed, that's what I said, right? Now read this line.
Hello, sir.
Now you know the solution. So read this line.
Am I audible?
Yeah, just
Hello.
Yeah, just one second. Yeah. So Syed Numan, this is for you. It is guaranteed that the given node is not the last node of the linked list. So that's what they have done, right? They have made this particular question with that purpose only. है ना? If you want to delete the last node, you won't be able to do it because उसके लिए आपको previous के next में null store करवाना है. You don't have access to it. Very simple answer is you cannot do it, but in any way, right? Yeah, you see, Narendra, it's in front of you, right? You don't have to traverse the list now. But it's only a specific case. It's only one question, right? Where you are doing it. It's a trick question. You know, don't get emotionally attached to this. It's just for fun, right? Actually, if you technically, if you see, did you delete the node that you were supposed to delete? No. You deleted another node instead. दूर से देखने में linked list is looking like that only, but you did not delete this node. This node is still there, right? So it is just for fun, right? It's not technically very correct, but yeah, I just wanted you to get, you know, familiar, like just have fun with linked list. That's why I took this question. Yeah, Sam, go ahead.
सर ये जो हम लोग हेड लेते हैं तो हेड को रिजर्व कीवर्ड है क्या जावा में? क्योंकि हमने हेड को कहीं पे मतलब
No. You can call it whatever. Like for example, what's start? You can call it start if you want. It's just that
तो
हाँ बोलो.
तो हमने तो कहीं उसे मतलब इनिशिएट किया ही नहीं, इनिशियलाइज किया ही नहीं, तो उसका यूज कैसे कर पाया? एरर क्यों नहीं आ रहा?
कहाँ नहीं किया, देखो ना आपको, वर यू देयर इन द फर्स्ट क्लास? Monday. Today is Wednesday, right? I took the
Yes.
first class on Monday. So I did this, right? If head is null, assign head to the first node, right? So when you are inserting in the linked list, if head is null,
हाँ.
that means there is no node as of now. So the node that you have created, just assign the reference of that node to head. So head को आप equate कर रहे हो ना
अच्छा
first
अच्छा
node
अच्छा
के.
अच्छा, हाँ ये ऊपर में ही है ना. ओके 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 ओके
So insertion के time पे this will be taken care of, right?
ओके
Okay.
ओके.
Yeah, sure. Okay. Yeah, Ravi Teja, go ahead, please.
Sir, yeah, I'm clear with logic, but sir, try to write the code at one place, sir. It is little bit confusing.
Try to write the code. Sorry, I didn't get.
From next question, write that code in only one place, sir, so that we can easily understand.
I didn't get your requirement. Are you saying that I write the code here only? Okay. Whatever. So didn't understand your point, but still. Okay. So let's move on. Yeah, Anmol, you were saying something.
सर जो आपने 12th वाली लाइन में करा है कि 1 मिनट सर लीड कोड करना, वो वाले, तो इसमें सर आपने ये जो हमने करा है, दोनों ही मतलब कि नोड्स पे सेम एड्रेस आ गया ना, ये जो node dot val is equal to node dot next dot val कर दिया है.
कैसे?
क्योंकि सर आप एड्रेस ही तो कॉपी कर रहे हो, क्या कर रहे हो इसको, या वैल्यू कॉपी कर रहे हो इसमें?
तुम बताओ.
सर वैल्यू कॉपी कर रहे हैं ना, तो अच्छा
एक नोड
अच्छा
है.
सर आपने वैल्यू कॉपी कर दी और उसके बाद इसी जो करंट नोड थी उसके नेक्स्ट को मतलब कि एक नोड छोड़ के कनेक्ट कर दिया. ये
और नेक्स्ट नोड को डिलीट कर दिया एक तरीके से ना.
ओके सर, ठीक है सर, समझ आ गया सर.
Sure. Okay. Can't take any more doubts for this one. No. Cool then. So this one is pretty straightforward. I'm just closing it. It was just for fun. Now let's get to the real agenda of today's class, right? Insertion in a circular linked list. Right? Acha, one thing that we also studied along with that question, we also studied how to delete a node in the linked list. That's also something that was missing. I did not tell you earlier how to delete from a linked list. So that also I told you today. And then we solved this particular question just for fun. Insertion in a circular linked list. So this is something that we'll be talking about now. And it's nothing. It's just that, they have asked me to tell you separately. That's why I'm telling it to you. But it's nothing on its own. Right? This is what a circular linked list is. And you only tell me if there is anything special about it. This is your normal linked list, right? Singly linked list we call it, because it only has one link. One node only has the option of one link, right? The next reference variable. This is your linked list that you have been studying, right? From left to right it's going, ending at one particular point. Circular linked list is nothing but taking the last node and then making it point to the first node, or which is also known as the head node, right? So this is your circular linked list. So don't confuse it with linked list with a loop, okay? Because it's not a linked list that has a loop. It's not having something like this. I'm not saying that it will randomly point to any node that came previously. I'm saying the last node will point to the head node. Okay, that's what I'm specifically mentioning. So this is what your circular linked list is, and there is personally, if you ask me, there is nothing special in this particular data structure. It's just the replica. It's exactly what we have been studying so far. It's just that only one condition is there, only one, which is saying that the last node is going to point to the head node. That's all, right? Yeah, please go ahead, Chanchal. And you guys please start wearing earphones when you are listening to lectures, because what happens, for example, if I unmute SK, so echo comes because I think probably he is also on speaker. So my voice is going to his laptop, coming back from his laptop. So that effect is there. So yeah, Chanchal, go
Hello.
ahead. Yeah,
Hello, Bhavya, how are you?
great. बोलो.
I was asking about this question only. आपने जब क्वेश्चन स्विच किया था तो मैं इसलिए आपको बोल रहा था अनम्यूट करने के लिए कि ये क्वेश्चन आप एक बार करा दीजिएगा, ये इसमें थोड़ा सा डाउट था और कोई
ये
दिक्कत नहीं।
सर्कुलर.
हाँ बस एक्चुअली में व्हेन आई वाज डूइंग द मॉड्यूल 2 फर्स्ट टाइम, तो उन्होंने जो इंस्ट्रक्टर थे उन्होंने एक सर्कुलर लिंक लिस्ट में इंसर्शन बताया नहीं था, सो
कोई
आई
दिक्कत
वाज
नहीं.
हैविंग डाउट फ्रॉम दैट टाइम
अरे हम
ओनली।
कभी नहीं बताते थे. You know what? I told you, right? I have taught how many batches? A lot of batches, right? I have never taught the doubly linked list, circular linked list. I have never taught it. All of them are placed now. So that's how trivial this is. It's, if you know what a linked list is, there is nothing conceptually new here. It's just a special type of linked list now. It's just a linked list that's coming with one constraint. Last node को लेके first node पे point करवा दो. That's the
Okay.
only thing, right? So I'll take it up, but yeah, there's nothing special here. So yeah, cool.
Okay.
Okay. तो यही है इसमें, मतलब बस हो गया. ये थ्योरी चाहिए तो इतनी थ्योरी है इसमें, right? This is a circular linked list. Okay, so now what? Let's take this question that AccuJab has given us. Insertion in a circular linked list. Given a circular linked list consisting of n nodes and an integer k, your task is to add the integer k at the end of the list. So the thing with AccuJab's question is, not only do we have to add the k integer that they have given us, it's also on us to add these integers also. ये भी तो हमें ऐड करने हैं, because these guys don't give us the linked list ready made, right? Linked list भी हमें बनानी है, उसको उसके first 3 nodes भी हमें enter करवाने हैं, and then we will go to the 4th node that is mentioned separately in the question as the k value. So it's like, for AccuJab's question, it becomes, you can say, every responsibility is on us only, right? So let me just क्या बोलते हैं, how do I refresh, or let me just delete these things that I have coded, right? I was attempting this before the class, and main and all, I am just removing these things. Okay, so now we have an empty slate. Let's start from scratch. Okay, insertion in a circular linked list. I told you it's just the same linked list with one additional concept, right? So first of all, tell me, is the idea of circular linked list clear to you? I'm just asking it for formality. If it's not clear, there is nothing more to tell. It's just that the last node will also point to the first node. So there is no node that's pointing to null. That's the only thing, right? There is no node that's taking you to null. Okay? So it's clear, very good, right? So that's the only theory that you can have here. So it's very easy. Okay. So I'm just copying what we had from for the node in our normal linked list. It had a data value int val. It had a link, right? It had a reference variable node next. That's also something that I'm going to copy here as well. Int val node next, and then I'm making a constructor to store int val, right? Saying this dot val is equal to val. Okay, that's all I'm doing. Also, let me make a class linked list, right? So it becomes more convenient to manage a particular linked list if I represent it in form of a class, right? उसी में function call कर दूंगा, उसी में function लिख दूंगा. It makes more sense because the function that I'm writing is about the linked list. That's why it makes sense to make the linked list class, and let's call it circular linked list, right? Circular linked list. So I'm not aware of the theory actually, but the way I see it becomes more intuitive is, instead of pointing to the head, listen to this carefully, instead of having a reference for the head in this particular question where they are asking you to insert at the end, it makes more sense to keep track of the last node. Do you realize? I'm just going to repeat myself. See, in this case, let's reuse this particular drawing. They are asking you to make a new node and insert it somewhere here, right? they are asking you to insert at the end. So instead of keeping track of the head from where I will have to jump and come again and again to the last node, I am just going to keep track of the last node in the first place, right? मैं head की बात ही नहीं करूंगा in the circular linked list. I don't care about the head. And there is another reason. Head क्या है? If I have the access to the last node, is this not your head? Tell me. ये head हो गया, right? Because last node dot next is what? It's pointing to the first node again. That's your head. So in this particular example, I am only going to take care of the last particular node, this particular node, because insertion भी मेरे को end में करना है. Insertion also I am supposed to do at the end. So it's better or it's more logical to keep track of this particular node, right? So I'm going to keep track of this particular node, as I said, and let's continue then, right? Sorry. I want to insert in my circular linked list. So let me just first of all make a reference that's going to store the last node, information about the last node of my circular linked list, right? Now what I'm doing is void insert at end, right? Insert at end. So you will be passed the value int val. That is something that you will be inserting. First of all, without using your brain, don't use your brain. अगर किसी ने insert करने को कहा है तो node तो बनाना ही पड़ेगा. If someone has asked you to insert a value in a linked list, first of all, you will have to put it inside a node. This is something you will have to do. So without thinking, just do it. I also don't think before doing this. ये तो करना ही है. This is something that we anyways have to do. Now think. Right, now think. Okay, inserting at the end of a circular linked list. One case that's very straightforward is if last is equal to null, right? What does it mean? You have an empty linked list. You have an empty linked list. After insertion of one node, how should your linked list look like? Or how should your circular linked list look like after you are inserting one node? There is nothing here, empty linked list. Now you want to insert your first node. Okay, let's say the value is 3. So what you want to do here is, in a normal scenario, what you would have done is, you would have introduced a null here. But by definition of circular linked list, the last node's next points to the head node. So first thing that you will do is, last is equal to n. To make a reference, your last is currently null. Now you want to make it point here because this is the last node, right? So this is the first thing that you will do. Second thing is this new node that you have created, n dot next is equal to n only. So the next should contain the address of which node? Of this particular node only, right? Is this part clear? Inserting the first node in the circular linked list. Let me allow you the permission to chat. Yes, from Sanket. Others? ठीक है? Cool. Cool then. This is how you will insert. Sorry, अरे यार, the first node. So all you need to do is last this is what you will do. Now if you have reached, let me also return from this place because we are done now. If last is actually null, after doing all these steps we are done, so I'm just returning from there. Now if you have reached line number 21 of the code, that means it's a non-empty linked list where you want to insert a particular node at the end. So let's tackle it from this case, right? This is the case. Now what you want to do here is, this is how your linked list looks, right? This is how your linked list currently looks. What you want to do is, you have taken a new node. You want something like this. The green ones are the new links. You want first of all this, and second of all you want this. Okay, these two nodes, these two links you want to establish, right? So first what you will do is n dot next is equal to this particular node. How will you access the first node? Last dot next. Then last dot next should be equal to what? This particular one. So last dot next is equal to n. So linking has been done perfectly, but there is one. So now the picture is something like this. This is removed and this is established, right? So now the picture is complete. It looks like this. This link has been established. This link has been established, right? So these two lines of code are there. There is one more thing that I would have to do. Any guesses there? I mean, I will not take guesses. I will just tell you here. This is where your last pointer is staying as of now. Now that you have inserted a node after that particular node, this is where your last pointer should move. So after this line, you will say last is equal to n, because now you want your last pointer to point to this particular node, right? So if we come here, what you will do now is this portion you have completed. Now what you will say is n dot next is equal to last dot next. You can't say last dot next is equal to n before doing this line, because if you say last dot next is equal to n, this particular link will be gone. Link to this particular node will be gone, and that's a very hazardous situation. If you lose link to this particular node, you are done. You have lost your complete linked list. You only have access to this node now, right? And you can't do anything. So first of all, you need to do where you don't have anything to lose, right? This is your new node. You don't have any information stored in its next variable. So just store this information. N dot next is equal to last dot next, right? And then what you will do is last dot next is equal to this thing. So this is how you will do it. Okay. That's what I wanted to tell you. So just to give another pictorial representation, if this is your circular linked list, right? If this is a circular linked list, let me say this is your last node, right? Now you have come up with a new node. What I'm asking you to do is, instead of saying I will remove this node and I will establish this link, you only have access to this node. So basically now whole of your linked list is gone. You don't have information about any of the other nodes. You only have access about the last node, and this new node that you have created, right? So first of all, before you remove this particular link, before you do that, do this. Okay, before you do that, first of all, establish this link. Establish this link because now you know where the head is residing, and if you know the head, you know all the other stuff as well. After doing this, take out this link, establish this link. So do you realize how it's happening? This is how it's working. So this is the first thing that you will do, and then you will do this. Okay, let me also draw this for your reference. This is gone now. Okay, so this is how you will insert it. Last dot next is equal to n, not minus, is equal to n. Last is equal to n. So I think we are done now. Let's take the inputs. So what are they giving us? First, they are giving us the number of items in the linked list. Then they are giving us the items of the linked list, and then they are giving us another integer to add. Pretty straightforward. I will go ahead and do it, but before that, do you have any doubt? Let me allow you to check. Yeah. Till then, let me just create that poll also. अरे यार. Okay, now in poll we have the option of launch. Okay, cool. Yeah, circular तभी होगा जब tail will be connected to it. Very good, very good. Okay, that's also one very good name of the variable that you can give. I am calling it the last variable because I was not able to think about it. But tail is also a very good variable name. So yeah, Kamar, you are right. N is not head, Dharmendra. N is the new node that you are coming up with, right? 21, 22, 23, that's the whole logic that I explained. People, can you pinpoint to what is your actual doubt here? Okay, before that, there is nothing. Cool then. So what I'm doing here is, I want to insert, I drew this picture as well, right? So I don't understand what your doubt is, but still, for the last time, let me explain it once again. Okay, this is how your linked list is looking like as of now. Okay, this is your last node, right? This is how the picture is. So now what I want to say is, this is your new node that you have come up with. What you actually want is, this is going to become the last node, right? This is going to become the last node, which is the new node that you want to insert here. So this should point to this particular one, the head, and the previous last node should point to this one. So that's what I want you to do. This is the first step, this is the second step, and the third step is take your last variable and make it point to this one. This is the third step. Okay, this will be gone and this will be your updated linked list, right? So that's what I'm doing in terms of code as well. N.next is equal to last.next, this particular line. This establishing this link means n.next is equal to last.next, so this particular node. Then last.next is equal to n. So what am I doing there? Last.next is equal to n, the new node. So I'm removing this connection now, right? I'm making it point to this. And now in the third, or you can say the final step, what I'm doing is I'm moving the last to the actual last node, because this was the previous last. Now I have inserted a node after it. So this becomes the last now, right? And it's already pointing at the correct position. That's the head node, right? So that is what I have done here. Cool. So if we come and take the input for the main part, scanner sc is equal to new scanner system dot in, right? So int n is equal to sc dot next int, right? So for loop चला लेंगे, int I is equal to 0, I is less than n, I plus plus. Now what I want to do is, I have taken the input n. I want to add these n nodes to my linked list. So first of all, let me create a linked list. Right? Sorry, what am I saying? Linked list L1 is equal to new right, and what I will do after it is L1 dot insert at end, insert at end sc dot next int. So let me tell you what I am doing here. I have made a linked list, and now what I want to do is L1 dot insert at end whatever you are getting from the console, right? And this thing you are doing for n times, that is in this particular case you are doing it 3 times. So first you are inserting 1, then you are inserting 2, then you are inserting 3. Because your function logic says you are inserting at the end, this is the order of insertion that's going to be there, right? 1, 2 and then 3, and then you are having this 4. So how will you add this 4? At the end only. So after having made this linked list, just do this line L1 dot insert at end what sc dot next int. Sorry, right? That is what you will do. So after having inserted the whole linked list, you're just doing insertion one more time. That's all you are doing. Okay. So now you need to print it. So that's also one interesting aspect, right? How you will traverse the circular linked list. The point is, normally what we do is, let's do something like this. Node head is equal to basically last dot next, right? And you don't have the access to last like this. L1 dot last dot next, right? Last of which linked list? L1, and dot next means it's going to point to the head only. So this is something you can define. Now generally how we traverse is something like this. While head is not equal to null, just keep printing, keep printing. That is what we generally do. In this case, we cannot do it. Okay, so it's like what we want to do is, we want to do something like this. So my head is currently pointing at the first node. I want to stop when my head completes the whole circle and comes back and point to the head again, right? So basically the value of head is this, right? So when my head becomes last dot next again, then I want to stop. So I will write this here, L1. In this case I want to stop, right? There's just one problem with this, right? There's just one problem with this, which is what? शुरू होने के पहले खत्म हो जाएगा ये. It will end even before it could begin, because in the beginning also head's value is this one only, na? So it's very convenient if you, instead of doing a while loop here, you do a do while. Okay, you write a do while here. So do what? Print, and what do you want to print? Head dot val, and head is equal to head dot next. So here we are directly traversing with the help of head variable, because this is not your usual head. This is some useless variable that we have just declared now. आप head को temp कर दोगे तो भी चलेगा, right? Because our main variable that we do not want to mess up is the last variable, right? The variable by the name of last. Right. So if I take this particular one, I take this example, Control C, Control V, run my code. Very good. What happened? Node. What is it? अरे यार, class. है ना? It will. Sorry. Very good. Insert at end sc.next int L1. Cannot find the symbol. Is there some issue here? Insert at end. This is correct only. L1 dot insert at end. Okay, this is confusing now. Why are we getting an error? sc.next int I is equal to 0, I less than n is equal to this. L1 is new linked list. Oh, sorry, circular linked list, right? Circular linked list. So that's why it was saying L1 तो कुछ है ही नहीं. It's a circular linked list. अरे यार क्या है लिंक same problem, circular linked list, right? Any other error? L1 dot insert, this was the same only. Okay, now I think it should work. क्या है 1 2 3 4 क्या? हाँ 1 2 4, adding 4 at the end, so it's working. Let me tell you what the error was. I just gave the name as linked list, but actually we don't have a linked list here. We have the circular linked list. No, we have modified the declaration, so that's the only thing. Otherwise there was no error. Yeah, there was no error other than this. Let's try to submit the code. ठीक है, all tests is passed. You are one step closer to a brighter future, both me and you. Okay, yeah, so now I can stop for taking doubts. First let's tackle these people. Yeah, SK, go ahead.
सर बस मैं उस टाइम पे डाउट पूछ रहा था कि मतलब कोड को रिमूव करके दोबारा से, आप तो क्लियर है?
हाँ हाँ, मैं सोचूं कि अब क्या कोड रिमूव करें. या खुशी, go ahead. Yeah.
हेलो सर. सर मतलब मेरा डाउट बस यही था, मुझे डिफरेंस पता करना था सर्कुलर और साइक्लिक लिंक लिस्ट के बीच में.
Cyclic random, anywhere just you're inserting, you're taking the link from the last node, anywhere you're inserting. That's a cycle. That's a that's a cycle. This is circular, means you're taking the uh, basically you are making the reference from the last node to the head node only. So that's forming a circle, right? So just to give you a pictorial representation, this is a circle, right? So basically if the last node points to the first node, then only circle will be formed. Any random link, if it is there, let's say this kind of picture is there, so this is not a circle, right? It's something like this. It's not a circle, it's a nothing. It's just a link. A loop is there, a loop is definitely there, so it's a cyclic linked list, but it's not circular, right? So that's the difference. Baki, yeah, Shubh, go ahead.
Hello, sir. Am I audible?
Yeah.
Sir, maintaining a last this tail variable, I'm not able to understand how we are maintaining a linked list. We would have lost the linked list. We are anyway moving
The
forward.
good thing here is, see, I understand your problem. You are having the thought that because we do not have the access to head, how are we even working? Is that what you are thinking?
Yes.
The good point in a circular linked list, or you can say the special point in a circular linked list, is you have access to the last node, right? The next node of the last node is again the head, right? So that means there is no need to separately store head.
What do you said, sir? Next node of the last node.
Last node, see, that's how you are forming a cycle, na? So this is your linked list. Okay, this is your circular linked list. This is the kind of picture you have. You want to store reference for this, right? You want to store this. I'm saying I won't do that. I'm just storing reference for this. Can I make out this particular variable using this? Yes, I can.
Sir, but if we are at second, then how we'll do that?
If we are at second, this I didn't get.
Sir, if we are at second block, then we'll not get, no, sir.
That's the point, right? We will not be at second. So it's like saying, what if my head variable, instead of this node, what if my head is here? It's like asking the same question. You maintain your head to be at the first node, na? Similarly, you are maintaining the last variable to remain at the last node, right?
Okay.
So that way always last dot next will point to the head node only, and that's what we did here. आप देख रहे हो? Insertion has been done. कहाँ गया? Where is that? Sorry, here. Insertion has been done perfectly. The last line that we are writing here is last is equal to n. So after the insertion is done correctly, we are making our last pointer move, right, to the correct last node, right?
But that is the new node, na, sir?
So where are you inserting the new node?
At last. But again you are last, you are equal to doing n, sir. So again getting connected to the new only, na, sir? How it is getting connected to the previous last or the first?
Last is getting connected to next. That's not new node. That's not what is happening. Last is a reference that you want to use to keep pointing to the last node always, right? So that's what you are attaining in this way. Last is equal to n karke, right?
Okay.
This is the linking part. This is where you are just updating the value of last reference variable, right?
Okay.
So that's how we are moving ahead. Yeah, Rajat, go ahead.
सर इसके प्रीवियस क्वेश्चन में मुझको थोड़ा सा डाउट था जो लोड उससे गया था।
डिलीट वाला बोलो।
हाँ सर, उसमें जैसे 5 नोड है हमारे पास और उसमें दिया हुआ है कि फर्स्ट नोड का एड्रेस नहीं है हमारे पास, कोई भी एक रैंडम नोड है। सर जैसे आपने val.next.val किया था और ये node.next.next, तो ये तो सिर्फ 2 नोड आगे बढ़ रहा है ना। जैसे मान लीजिए ये एड्रेस दिया उसने सेकंड नोड का और हमको फाइंड करना है 5th नोड, तो ये 3rd और 4th ही नोड तक तो पहुंचा, ये 5th नोड तक कहाँ पहुंचा?
एड्रेस सेकंड नोड का दिया है, वही तो डिलीट करना है ना?
जैसे ये नोड 4 की नोड थी, ये एग्जांपल इसमें 4 का नोड दिया हुआ है। और मान लीजिए ये 5 या 6 की नोड थी हमारे पास, 5 या 6 की नोड हो, 6 डिजिट 6 उस वैल्यूज की नोड हो जाएगी हमारे
लिस्ट है,
पास,
that's what you
और
are saying,
एड्रेस
right?
हमारे पास ये सर
हाँ
और ये नोड हमारे पास एड्रेस हेड का तो नोड आया नहीं है, एक
हाँ
रैंडम
नहीं
नोड
आया।
आया है। तो इसमें मान लीजिए सेकंड का नोड आया है और हमको
हाँ।
फिफ्थ का नोड करना है डिलीट।
फिफ्थ का नोड
तो
करना है,
सर ये
नोड जो डिलीट करना है उसी का तो रेफरेंस दे रहे हैं। सेकंड का नोड आया है, इसका मतलब वही तो डिलीट करना है।
अच्छा अच्छा
हाँ, जो नोड है, जो नोड दिया है उनने वही डिलीट करना है।
अच्छा, ये डाउट था मेरे को।
नहीं, वही देखो ना, यू आर गिवन एक्सेस टू द नोड दैट यू वांट टू डिलीट, है ना?
ओके सर।
Yeah, this is the last doubt that I am taking. Yeah, Vikram.
हेलो सर।
Yeah. I am not able to hear you, Vikram. Okay, there is some disturbance from your side. I am not able to hear you. So yeah, Vipul, go ahead.
Hello. Sir, as we were in the module 1, Adarsh sir has shown us the visualization of the sorting methods of all the kind of sorting. So can we have the visualization of the linked list if we have on the any web server or anywhere?
Acha. I
The
don't know, but we can.
graphical visualization they have shown us.
You can Google for it. I don't know. So yeah, see, this thing is there, right? Something like that is happening. Okay, whatever. How do I escape it? Yeah. So linked list is there. What do we want to do? You can just keep exploring this particular one, right? What is it that they are allowing us? Okay. Create. Empty. Okay. Search. Okay. So can I do a undo here? No. Insert. So this is a good enough thing, right? You can use this to visualize. I am pasting the link in the chat. Thanks for asking this question, right? I actually didn't think about it. I'm pasting in the chat, right, Vipul? So this is something you can use. So here you are given the functions, and then you can keep adding it. Let's say after specify go whatever. So this way you can just keep adding, right? Head is there, tail is there. So these things you can do. Anyways, so thanks for asking, right? Otherwise, I would never have told you about it because I never referred this stuff myself. So good. Okay. So we've inserted to the circular linked list, right? Yeah, that's pretty much all we needed to do for a circular linked list. Now that the idea of circular linked list clear to you and how we inserted the value there. I've launched the poll right now. No. Right. Okay. Cool. Clear to the majority. Okay. Cool then. So let's talk about the doubly linked list then. Right. Circular is a very much straightforward. Doubly is a little bit not tricky again. It's also very easy only. But there is some some new addition in the doubly linked list. It's not if that was on a difficulty level of 2, this is the difficulty level 3 out of चलो उसको 3 मान लो, इसको 4 मान लो out of 10. Okay, so both are pretty easy. Insert a node in a doubly linked list. So before we go and insert a node in a doubly linked list, let me just tell you what a doubly linked list contains of, right? What it looks like. So this is your singly linked list, as they say, right? Where you only have movement in a single direction, right? The linked list that we have been studying since day one. Doubly linked list means they want you to move in both the directions, right? So if I want to draw the same picture, it will look something like this. This is the next pointer allocation. And this is the previous pointer. So 2-3 things to note here is this is your head. That concept is still the same, right? The previous for head is null, right? That's the first thing. Second thing is the next for this particular variable. Let's call it a tail. Let's also maintain this information, right? So for this linked list, we will also keep a track of head and also keep a track of tail, right? Because you see the movement is bidirectional, right? At any given node, you can traverse to the right also and you can traverse to the left also, right? So the movement is bidirectional. So let's have a reference to both of these, the head also and the tail also, right? So head का previous null है and tails next is null, right? And that's it. So the node structure will have something like this. It will have int value, but it will also have node previous and node next. Okay, so this is how the structure of node will look like, and I think that's all, right? If you have a doubt, you may ask it now. I am opening the chat for you guys, right? I am also, I mean, if it's clear, you can mention yes. Otherwise, if we have same value as the head, will print function work. If we have the same value as head, didn't get your question. Where? I'm not able to. Yeah, Adil, go ahead.
Yeah, like does it have multiple addresses or it's simply like
see, don't consider node as node only, okay?
Okay, yeah.
So that idea is still the same. It's just that now your node has, instead of having 2 components, it has 3 components now.
Well, like that component particularly, like we were addressing it like one is the address and one is the value, right? So like now it has 2 addresses and
2 address, yeah. One address for storing the next node, one address for storing the information for the previous node. So it's making the movement bidirectional. Do you see that?
Yeah, that is fine. There's the only the 2 address thing I needed to ask.
2 address, yeah. It's storing 2 addresses. First is for the, you can say one is for the next node, one is for the previous node.
Yeah, thank you.
Yeah, definitely, right. Okay, so now let's see how we will insert, right? That's also pretty straightforward. We will see insert at end and insert at start, okay, or beginning. So first of all, every linked list will go through this. If head is null, right, what we will do is just we have made a new node, right? Let's say 5 value insert करनी है. ऐसा कुछ दिख रहा होगा अपने को, right? This should also be null, this should also be null, because since it's a new linked list, this is the first node and this is the last node as well. So both these, there is no next node, there is no previous node, so both are null. And what we will do is we will make our head point to this, we will also make our tail point to this, right? Because this is the first node, this is the last node, so head bhi hai, tail bhi hai, right? Nothing fancy here. So we are thinking about inserting at the end, right? So let's say now we come up with a node and now we want to insert the value 7 after 5. Okay, how is the picture looking as of now? This is where your head is also, and this is where your tail is also pointing. So now what you will do is you come up with a new node 7, right? after having inserted the data, this is how it will look like. What you want is you want this link to be there. Let me just draw it with green. You want this link to be there as well, and you want here to be a null, right? That is what you want. After having done all these things, you want to move your tail to this particular node. So let's see how you will do this. Okay, at any given point, last node will be represented with the help of what? Tail. So what you actually want is tail dot next is equal to what? New node. New node dot previous is equal to what? Tail. Right? This is by default, this is null only, right? So don't need to write that explicitly. And now what you want is you want to move your tail to the newly created node, right? So that way your T will come here. So after inserting correctly, what you have achieved is your head is pointing to the first node, your tail is pointing to the last node. This is something that you will keep on doing. So let's now code the insert at end function. But before we go there, is there any doubt that you guys have? Because to me it seems pretty straightforward, and it's nothing different from a singly linked list if you ask me, right? Okay, so you are saying no for the question that is there any doubt, so you don't have any doubt. Okay, can we use head also? So Shivan, what we will use that when we insert at the beginning, right? So previous code, please watch it after the class now. Okay, I will share all the codes with you, but now I can't go back. When we will do reverse linked list, and what are the next questions? Oh, let's do reverse linked list now. After this one, Mohit, we will go to reverse linked list. Okay, don't worry. Break for 5 minutes. That we can do. So take a break for 5 minutes. We will meet back at 9:40. Until then, I can address some of your doubts also. Let me put a break on the chat. Come back at 9:40. Come back मतलब meet तो leave नहीं ही करोगे, अपनी सीट से उठ के भागो और whatever you want to stretch yourself, drink water, do that and come back in 5 minutes, right? At 9:40. Yeah, if I don't turn on the chat, I'll not be able to attend the genuine doubts, Mohit. Reverse we will take up next. Can we? Don't see a doubt here. Which is better? So it's like from the first appearance, this one looks better, right? But yeah, so it's like doubly linked list has all the properties of a singly linked list, right? That is anyways there. So if you want to kind of say that what is the disadvantage of using a doubly linked list, it's just that for each of the nodes you're having 2 pointers, right? 2 reference variables that are responsible for storing address. So that's the, you can say, extra space that you are taking for each node. Other than that, doubly linked list is actually having all the possibilities of a singly linked list. Now, if you do not use the previous, you can say previous reference variable, only use the next variable, that's same as your singly linked list, right? So that is anyways there. Repeat again. So let me repeat that till the time we have a break. Okay, inserting the first node is not an issue. Now the point is, what will happen when we want to insert the insert another node and we want to insert it at the end, right? So this is how the picture looks like. I've inserted the first node, right? And this is how it looks like. Now I want to insert the next node. So I told you, first of all, right, just blindly make a node. Because when I'm asking you to insert a node, definitely first we have to make a node. So this picture you have already. Now what you want is, you want a connection like this, you want a connection like this also, and as of now your head is also pointing to this, your tail is also pointing to this. Ultimately what you want is your tail should point to the last node, which is this one now, because after inserting it at the end, it will be at the end, so tail should technically point to this node, right? So all we will do now is tail dot next is equal to n, yes. N dot previous is equal to tail, yes. Tail is equal to n. So what have we done? Tail dot next is equal to n, this link. The n dot previous is equal to tail, this link. Tail is equal to n. So we have taken this from here and we have then moved it to this one. So head is still pointing to the first node, tail is now pointing to the last node, right? So that's what I did, right? So I'm just opening the chat once again. If you have a doubt, you can ask it on the chat, or you can ask it here also. And once you, let's say, have a doubt, you raise your hand. If you don't have a doubt anymore, please also make sure that you are lowering your hand. Can we make doubly linked list to circular? Yeah, Chirag, you can do it, but we are not going to see it in our class. But can you do it? Yes. So it will be something like this. Let me do it after the break, right? Or let me do it here only, because I don't want to cover it in the class. But since you are asking, let me show it to you. This is something we will have, right? So this kind of structure you have for a doubly linked list. Now, instead of pointing to a null, the previous will go and point to this particular node. Instead of pointing to a null, the next will go and point to this particular node, right? N dot previous is equal to tail. So Ankit, the point is, why do you have a previous pointer in your doubly linked list? You want every node to store the address of the previous node as well, right? So for n, because you are inserting it next to this particular node, for n, the previous node is this. So n dot previous is equal to tail, because tail is the previous node for n, right? Tail is equal to tail dot next. Yeah, now you can write that, Vibhuti. Yeah. Can you please swap kth nodes from end? Swap k nodes from end. I think I've seen this question somewhere. We'll see if we have time. Why are we not using pointers in singly linked? Is it easy to insert at end, right? Why are we not using pointers in singly linked list? When are we not using that? We are using that only. Pointer, like we don't have pointers in Java, we have reference variables, but this reference variable only I'm calling as a pointer. Doubly linked list में हम दो nodes insert कर सकते हैं. एक बार में तो एक ही कर पाएंगे कंवर, right? We will be calling a function. We will be doing one operation at one time. In circular question in class, why you not make next is equal to null in constructor? Vamsi, that's the definition, right? Circular linked list does not have any next as null. That's the first point. And the second point is next is by default equal to null only, right? By default next is null only, so we don't need to explicitly code it in the constructor, right? Yeah, Shubham, I'll take it out now. Go ahead.
Yes. सर वो टेल डॉट एन वो टेल को कन्वर्ट करने के लिए सर, नेक्स्ट आगे बढ़ाने के लिए.
हाँ, आप जानते हो ना, अब टेल को क्या करना चाहिए? टेल शुड नाउ पॉइंट टू द लास्ट नोड. यस सर. लास्ट नोड. जैसे ये तो फंक्शन में वैल्यू को रिटर्न नहीं कर रहा है, जैसे मैं नोट टाइप का वो फंक्शन बना दिया तो वी आर नॉट रिटर्निंग. यस, तो रिटर्न हेड कर दूंगा यहाँ पर सीधा. हाँ, return head कर दो, या फिर we don't need to actually return anything, right? The thing is, this tail head, this is getting stored as a property of linked list. कि इस linked list का head ये है, इस linked list का tail ये है. So you don't need to return anything as such. Yes, sir. So we are done with that. Yeah, Devendra.
Hello, sir. Actually, my meeting got disconnected. Sir, can you explain that 3 lines of code? Tail dot next is equal to n.
Okay.
S dot previous is equal to tail.
Okay.
So can you explain that?
Is there something that you are able to make out from this on your own? Like, were you there when I told you what a doubly linked list is?
Yes, sir. I'm there that time.
That time you were there. So tell me what this means.
Tail dot next.
Let me tell you what the earlier configuration was. So this is how it was earlier, right? Tail. So now tell me, because there is only one node, I said head is also this, tail is also this. Now tail dot next is equal to n. What does it?
Sir. 7. But next is equal to n.
This thing, right?
Yes, sir.
And n dot previous, it's n not h. N dot previous is equal to tail, right? So because I also want to store information about the previous node, for n, what will be the previous node? This tail node. So this I am doing. Then because ultimately I want tail to point to the last node, this node I have inserted at the last. So what will I do? I will make this pointer move here, right? So ultimately this should be the picture. So that I am achieving through this line, right?
Tail equal to n. Okay, sir. Fine.
Yeah, that's what I'm doing. Okay, cool. Now let's go ahead with the coding part of this. Right, I had already declared some of the things, but let me just delete as you guys mentioned. Right, this I'm deleting. Main function. I am okay. This is fine, right? Yeah, okay. So now I have to declare a node, and this time the node will have a previous reference variable also, right? So node int val node next and previous, and then node constructor int val this dot val is equal to val. Then let's create a linked list. It's a doubly linked list only, I'm not naming it like that, okay? Then in linked list we will have a head, we will have a tail, right? Now let's code that function. Void insert at end, right? Int val. What do you have? First create a node blindly. Node n is equal to new node. Pass the val, new node created. If head is null, that's the easiest condition to tackle. So let's tackle that. If head is null, head is equal to n, tail is equal to n. That's it, nothing more. And return also, because at this point we are done, right? We don't want to unnecessarily go further. Else, or you can say at this point, head is not null, then only we will reach this particular line. So what we will do here is those three lines. What we want to do is establish a connection from tail to the new node. Tail dot next is equal to new node. Establish a connection from new node to the tail. New node dot previous is equal to tail. Update the position of tail variable. Tail is equal to new node. I think we are done, right? So let me solve this question in parts. So what they are saying is, this is actually comparatively, you can say, next level of the previous question, because in previous question what happened was we coded only one function, inserting at the end, and that helped us in creating the linked list also and solving the question also. Here what they have done is they told you that 5 is the size of the linked list, 2 is the number that you have to insert, and this is the linked list. So how they want you to take the actual linked list is by inserting at the end 1, then 2, then 3, then 4, then 5. And what they want you to do is this number 2 is, with this number 2 is, they want you to store it at the beginning. So now your linked list will look like 2, 1, 2, 3, 4, 5, right? 2, 1, 2, 3, 4, 5. So that's one thing. We have coded insert at end. So let's take this as our input, and just for seeing whether we are correct or not, let's print this linked list, and then we will also add this at the beginning. So we have to code one more function, insert at start or insert at beginning, whatever. So let's take this input, scanner sc is equal to new scanner system.in, right? Scanner sc is equal to new scanner system.in, and what we want to do here is int n is equal to sc.next int, then take a basic for loop. So these things that I'm doing, I'm just repeating from what I've done, 4 or 5 times earlier also. So why am I taking a for loop? Because I know these many numbers I want to take as the input. And before I take a for loop, let's also take the number we want to insert. Otherwise it will be lost, right? sc dot next int, right? And now let's create a linked list. We have created a linked list. Now what do we have? I is equal to 0, I is less than n, I plus plus, right? And what do we have here? L1 dot insert at end, and then sc dot next int. Okay, so these things I'm coding in a, you can say, speedy way, because this is something we have already done, right? Now let's try to print it. Node temp is equal to head, right? While temp is not null, right? Something like this. So I just want to check if I am getting 1 2 3 4 5 printed correctly or not. I'm not expecting the answer at this point because I have not coded the whole question. I just want to see 1 2 3 4 5 printed, right? Maybe we made some mistake, is it? We probably did. What is it that we did? While temp is not null, temp is equal to temp dot next. I told you, right? This is something that's a very common mistake. Print तो कर दिया, but increase नहीं किया उसको. So this is also something that will spoil your code. उसके चक्कर में क्या हो रहा था? वो infinitely चल रहा होगा, इसलिए अपन को output नहीं मिल रहा था. 1 2 3 4 5. So basically we have inserted into our linked list correctly. Now we just need to make one more function, insert at the start. Is this clear to you? I've launched the poll this time. Okay, cool then. Okay, so we have seen inserting at the end. Now let's also see insert at the beginning. Insert at start. So int val will be given to you, and then you will code something. So let's see it in the pictorial representation. So this is also that you are also supposed to do, right? Insert karna beginning mein, don't do anything. Just take your pen and paper and see what you have to do. See what the picture will look like after you have inserted correctly, and try to make those changes. It's as simple as that, right? So this is your linked list, right? यहाँ पे null है, a null here as well. This is your head, this is your tail, right? And what you will do now is okay, so you want to insert at the beginning, right? So what you want to do here is, first of all, this is your node n, so you want to have a link like this. Then you want to have a link like this, right? This will anyways be null. That's it. And you want to move your head here, right? Same thing that we did for tail. अब इस बार head के लिए करनी है. क्या हो जाएगा? n dot next is equal to head. Instead of saying tail dot next is equal to n, we are saying n dot next is equal to head, because we are inserting before head. So what will come next to the new node? The previous head, right? N dot next is equal to head. Head dot previous, which was null, is equal to n, because now previous to head we are inserting n, right? And after this, head is equal to n, because now that you have inserted something before the head, that has become head, right? Is this thing clear to you? I'm opening chat this time. Is this thing clear to you? ठीक है? Cool. Okay, let me not close the chat this time. Okay, but only ask questions related to what we are discussing. Okay, head is equal to head dot previous. Yeah, Chirag, definitely. Okay, so insert at start. First is what if head is null? That is also something that we will take here as well. First of all, node n is equal to new node, head, pass the val, and then what we want to do is, first of all, if head is null, that if linked list is empty, head is equal to n, tail is equal to n, right? Otherwise, and return also, right? Otherwise, what we will do is, so what we have to do here is head dot previous, right? Head dot previous is equal to n dot next is equal to head, and head is equal to n. That's all, right? So let me do L1 dot insert at, what's the name of the function? Start, right? Insert at start the value k, and then I think the rest of the function we need to just repeat, right? Run code. Now we should get 2 1 2 3 4 5. 2 1 2 3 4 5. Let's try to submit it. ठीक है, congrats. Now, any doubt? Line 28 देखते हैं. What happens if we do not write return in the block, in the if block? So Nirank, right? So if you don't write return here, right, you will keep doing these things, which doesn't make any sense, right? So यहाँ का job हो गया ना. For the case when the linked list is empty, this is all you needed to do. Head is equal to n, tail is equal to n. So it's better that you return from there and then write the logic for the general case, right? Line 28 में क्या है ऐसा? अच्छा, okay, you are saying because earlier it was spelling mistake. Okay, got it. Can we do traverse from the tail and then add a new node? Yes, Chirag. If like just for theory perspective you are asking, yes, you can do it, right? Achha, one advantage because of the question that Chirag asked, doesn't matter whether you insert at the beginning or at the end, time complexity is O of n only. In our linked list, if you insert at the beginning, the time complexity will become O of 1, but if you insert at the end, the time complexity will become this thing, O of n. But here it's O of 1 only for both the cases. Share code, I'll update the code doc. Yeah, I do update it daily, right? So don't worry about it. I'll update it today also, right? है ना? So you will have all the codes here. Cool. So this is also done. Then we will have this question of reversing the linked list. Okay. So before we move to that, any questions? Doc का link भी ले लो. Control C, Control V. How to solve clone a linked list with random pointer? So that's a very good question. We will take that up later. But try to solve it once you can try to solve it now, because today we developed some more understanding of linked list. So try to do it today on your own. I would say it's a medium to difficult question. It's definitely not easy. Okay, not easy at all. So try it yourself once. We will take it up later. If you would not have kept the track of last element as tail, then for adding node at the end, हाँ पूरा traverse करो फिर वो सब करो, right? It's a time waste. Code इधर पे मिलेगा विशाल, in this doc, right? I'll mention it here. I'll paste it here. देखो ना पुराने classes के codes आएंगे. updated till yesterday, है ना? Insertion of two linked list, intersection of two linked list. Yeah, that's also something I plan to take if we have time, है ना? यार एंथुसियाज्म कुछ कोडिंग का ऐसा खास नहीं, तुम लोग को पढ़ाने के चक्कर में जितना पढ़ता हूँ उसी का एंथुसियाज्म है मेरे को. उसके अलावा it's the only motivation I have is money only. Other than that, nothing. I'm talking about the job side. शाम को पढ़ाने में I like teaching, that's why. And about the other aspect of coding that I do at the job, money. और बाकी when you solve these, अभी आप देखो, just observe this one thing. When you code here and you solve these questions, ये जो AccuJob ने बहुत बढ़िया सा एक prompt बनाया है, congratulations, all the test cases passed, all this stuff that we have, it gives a good feeling ना. ये congratulations, ये पूरा ये जो गुब्बारे छूट रहे हैं सब हो रहा है, right? So that's also a motivator at this particular stage. That also motivates. I mean, when I was a student. So in real life, when you will have actual action items assigned to you, and when you will do that, see that actually getting implemented somewhere, that's a very good feeling, right? Money तो चलो एक driver हो गया, that's a important factor, but this is also a very satisfactory feeling that you are able to implement your knowledge to achieve something that is really helpful, right? That is helping people in real life. तो वो तो एक अलग ही satisfaction है. So enthusiasm तो आप चिंता ही मत करो, वो तो जैसा मेरा है वैसे आपका भी रहेगा. I don't have any doubt there. और यहाँ के enthusiasm की बात यह है कि I am more excited in teaching you guys than I am excited to do my job, because I like teaching very much. So it's like when I come here teach you guys in the class, I feel like I have a purpose. So I'm more interested in this than anything else. तो उसकी तो बात ही मत करो. How to take input from user without knowing the size of the linked list? So that you can, okay, good question. That you can keep doing by, there is a function called as has next integer, right? So that you can use. So if your console has any next input, then only it will go ahead and take the input. So Google the implementation for that, right? And you can use it to do like that. W linked list ka screenshot, where? Arey, I will paste this whole thing for you, but still if you want to take some screenshot or anything, you can take it, but I will paste this whole thing. If you have a tail reference in single linked list, we will have only O1. Yeah, there also we can do this. Yeah, right? Insert at end, insert at start. So if you want to take a screenshot, you can take it, right? Other than that, let's move to this question. Reverse linked list, something I should have told you earlier only, but I could not. So reverse linked list is a very important, it has a lot of applications, right? Now that you will learn to reverse a linked list, you will realize that from this point onwards, you will use it in a lot of other questions also, right? Reversing of a linked list. So it's very important. You can consider it as a theory point only. जैसे हम लोग insert, delete, all these stuff we are watching, right? Reverse is also equally important. So given the head of a single linked list, reverse the list. Question is very simple. You are supposed to reverse the linked list, and it's actually very interesting also. It's not very straightforward. It's not very easy. But let's see, right? 1, 2, 3, 4, 5. You are supposed to make it like this: 5, 4, 3, 2, 1. So you're reversing the links. It's becoming exact reverse of what it was before, right? So that's what you want to do here. And let's take a small linked list and try to solve, like try to come up with some inputs, right? So 1, 2, 3. Back to single linked list. No cycle, no double, whatever, right? Back to single linked list. Now you want to reverse it, right? So you want to reverse it. How will you do it? So basically for this node, if I talk about, or let me talk about a random node. Okay. For this node, if I talk about, what you want to do is, I'm drawing it with a green pen. This kind of link you want to establish, right? That is what you want to do. But in order to do so you want to do something like this, right? 2.next is equal to 1. I'm just taking values just to make you understand that this node.next is equal to this one. That is something that you want to do. But in the process of doing that, what you will lose is, you will lose this node, you will lose this connection, right? So that is one problem, right? What is one problem? When you establish the reverse link reference to the next node is gone. Okay, reference to the next node is gone. Whenever you do something like this, you will not have any way to reach this node now. Okay, that is one problem. We will solve it, but that is one problem, right? Second thing, let's see if there is any other problem as well. So what we can do, very easy thing that we can do to solve this particular problem is, so this is our current node, right? This is our current node that we want to tackle. So let's explicitly make a variable and take its help to store reference for this particular item, right? जब मैं कर रहा हूँ ना, current.next is equal to this node. When I am doing that, before that, let's store this somewhere. So let me call it as, let's not use the name next. Let's use something more like something different to avoid confusion. Next, left. Let's call it right, because it's coming to the right of our previous node na. So this is the current node, this is the previous node, and this is the right, or you can say the next node. I am just not using the name next because we have dot next also, so I don't want you to get confused there. So this is the right one. Okay, so now if you make this particular thing, now if you do current dot next is equal to previous node, this link will be established, this link will be gone, but you still have access to this particular node here. You still have access to this node. Do you realize this? If you're comfortable with this thing, we can go ahead and try to apply our logic on a bigger linked list also, right? So I'll allow you the permission to chat. You can ask your doubts, okay, and tell me if it's clear or not, right? Yeah, go ahead. Yeah, go ahead.
हेलो सर।
हेलो
सर, जब सर हमने करंट डॉट नेक्स्ट करा प्रीवियस मिलान को, तो ये तो 3 वाला लिंक है, ये सर कैसे छुपा है?
3 वाला
जब हमने सर करंट डॉट नेक्स्ट किया है, हमको प्रीवियस मिला है जो सर 1 है, तो जो सर ये जो राइट पोजीशन पे है जो 3 है, वो सर हवा में रहेगा, कैसे रहेगा?
अभी हवा में रहेगा, राइट? बट इट्स लाइक इसके आगे भी कुछ लिंक लिस्ट होगी, राइट?
यस सर।
So that is who is holding that now? This right variable. That's what I said, right? You will lose this link. So you want to in order to store it, you will have to store this information somewhere, right? So before breaking this link, you will store the information about address of 3 in a variable called as right. So it's like we're maintaining 3 variables: the current node, the previous node, and the right node, right? Because of this problem, right? Because of this problem.
Thank you, sir.
है ना? Next, what you will do is, see, you have reversed the link for this one. You have reversed the link for the current node. So for the next iteration, this will become the current node. The next node will become the right node, and this node right here will become the previous node. So do you see? That way we will keep moving forward and reversing the links. Let me take a bigger example and do a dry run on the whole thing. Okay. So we will do right is equal to current dot next. Yeah, we will do that. Right. So let me explain the whole thing again with the help of a bigger example. Right. So this is how your linked list looks like. Let's call it 1, 2, 4, 8. This is your linked list. You know what you want. At the end is 8, 4, 2, 1. This is what you want. Okay, that's very clear to you. So now let's get started with this question. Okay, what you want to do at the beginning? At the beginning, you want to tackle this node, right? So let's name it as current. right? At the beginning, so by logically thinking, I'm saying this. So for the current node, what you are doing is you want to equate the next to the previous node, right? When we are at the first node only of our reversed linked list, for our reversed linked list, this node will become the last node, right? So at the beginning, what should our previous variable store? At the beginning, like, can we make it point to null? Null is not any particular entity. Null does not mean anything. But because I want to make it point to null, I'm just equating previous variable to null, right? So basically what I'm saying is, for the beginning, if I say previous is equal to null, my current is pointing to this particular node, and my right will point to current.next, that is this particular node. So does it make sense to you? This portion has been taken care of because I have taken right variable to take care of all the other nodes. Now for this particular node, all I want to do is I want it to have a null in its next variable, right? So how will I take care of that? At the beginning, I will allot the value of null to my previous variable, right? Is this point clear to you? Tell me. So for the first time, what I am doing is, this is what I am doing. I am saying that previous is equal to null, your current is equal to head, and right we will just keep assigning as and when we go. So whatever is the current, we will just say right is equal to current dot next. Okay, we will keep doing this. So now let's try to move forward, right? So what we will do is, to increment these, we will say previous is equal to current and current is equal to next. Okay, because we have access to this, not next, right? Because we have access to the right variable, right? Now let's deal with the updated value of variables, and let's see if we are able to establish a pattern or not. Okay, this is the current node, right? Right is equal to current dot next. This is the right node, and this is the previous node. What I want to do is, I want to do this only. Current dot next is equal to previous. So this link will be established, and also observe, this link is gone because यहाँ पे null कर दिया मैंने. This link is gone. Now this link is established. A link like this is established, that means this link is gone, right? So now what's the picture looking like? This is how it is looking like. So we have reversed this portion, right? We have reversed the link for this particular node. Do you see? Now we want to move our iterators further. Previous is equal to current, current is equal to right. Okay. So previous is equal to current, current is equal to right. So current is also here, right? Now what we will do is, we will assign the correct value to right now. Right is equal to current dot next for the next iteration. So right will come here. So let me just delete it from here, right? Now what we want to do, we want to establish this link, right? We want to establish this link. So what we are doing is, in a way, this is our first step, this is our second step, this is our third step. It's like moving on, right? To move on further, to move our iterators further, this is the third step that we are doing, right? Again, current dot next is equal to previous. So current dot next is equal to previous. This link is gone, right? So if you carefully see, for the reversal, the code is actually one line only. Current dot next is equal to previous. It's just that how we are taking care of the previous and right variables, that's of importance here, right? So that is done. Now second step is done. Now previous is equal to current. Previous is equal to current, current is equal to right. So previous will come here, current will come here. Okay, and let me just remove the older values, right? And right is still there. Now what you will do is, right is equal to current dot next. As you can see, right will move to null. Okay, because, and it actually deserves to move to null only, because now right does not have to worry about anything here, right? So what you will do is right will move to null. So let's say right is moving to null. Okay, right? Now what you have is current dot next is equal to previous. So this kind of link will be established, right? And previous is equal to current, current is equal to right. So previous will come here, current is equal to right से क्या हो जाएगा? Current will also become equal to null, right? Do you see that your linked list has just gotten reversed? 8 is pointing to 4, 4 is pointing to 2, 2 is pointing to 1, 1 is pointing to null. Do you realize this? And at this point, P is actually the head of your reversed linked list, right? It's yeah, we are using 3 reference variables, right? Why we are using 3 reference variables? ये तो clear था कि एक reference previous के लिए चाहिए होगा and 1 reference we will need for the current variable, because current dot next is equal to previous, something like this we will be doing. But while doing that, we will lose the control, or you can say lose the access of all the nodes which are coming after the current node. So for keeping track of that, we also like took a new reference variable called as right, है ना? So not able to understand previous is equal to current. So Mohit, after doing current is equal to, you know, this thing, current dot next is equal to previous, we want to keep doing that with all our nodes, na? So previous is equal to current is just making our previous variable ready for the next iteration. Are you getting it? If this is the current node, if this is the current node as of now, for the next iteration, I want this to become my previous node. If this is the right node for this iteration, for the next iteration, I want this to become my current node, because I want to process this next, right? That's why these lines, right? Yesterday we did it using recursion. Is it possible that way? So this way is more intuitive, right? So let's not go there. Easy way is recursion? No, Vikas. Yesterday you did not touch the links of the linked list. Yesterday you did not reverse the linked list. Yesterday you just printed the linked list in reverse. Today you are actually reversing the links, right? Time complexity O of n, simple O of n, just one loop O of n, right? So code is not anything, like code is not problematic here. So Ishwar, that is happening at the end, right? Current is equal to null, right is equal to null. So at the end what will happen is, when you reach this particular node, right's job is to take care of the next node. But because we are already at the last node, when you do right will actually store null, है ना? And now because current is also here, this is the picture that it will look like, right? So for the last link reversal, this is your previous, this is your current, and how will you assign your right? Right is actually current dot next, right? Right is current dot next. So right will now go to null, which is correct also, because for the last node you are doing this. So now there is nothing else left to change, right? There is nothing else left to reverse. So right is equal to null because there is nothing else that is there after the current node. Then current dot next is equal to previous, establishment of this particular link, right? And then you have previous is equal to current, so previous will come here. Current is equal to current dot next, that is not current dot next, current is equal to right, so basically current will move out to null. So that means that now there is no node left to reverse. You are done with your job. And after doing the reversal, previous variable will be you can say standing at the head of the reverse linked list, right? Right. Don't confuse today's thing with what we did yesterday. Yesterday we just printed. Today we are reversing the linked list actually, right? so that if you print the linked list in the normal way, it will print the reverse only because आपने reverse कर दिया है. In recursion, do we include space of recursion stack? Yeah, we include space of recursion stack. Yeah. How did the next part of first become null? So Chirag, when I started the question, what I will do is I will start by saying previous is equal to null, right? So that this logic works. This logic will work, right? Time complexity O of n, right? I hope you will have some sort of better clarity now. Let's start coding. So in LeetCode we have list node. List node, what is it that we have? Current, previous, right, है ना? Current, previous, right. Right we don't need to initialize. Previous I am initializing as null. Current I am initializing as head. Right. So let's do our job now. While, so you will keep solving this question till current becomes equal to null. Till then you will keep doing. What are you doing? Right is equal to current dot next. Right. Then current dot next is equal to previous. This is the actual reversal. This is your main point. Now you are just moving the variables for the next iteration. So previous will come to current and current will go to right. Do not even think about writing current is equal to current dot next because you have just now reversed the link. आप पीछे चल जाओगे, right? Current is equal to current dot next will not work here क्योंकि आपने क्या कर दिया है? This is your current. Current dot next is this, but you actually want to come here, right? So current is equal to right. है ना? Node is equal to insert at head. Okay, there. Node dot next is equal to head. Yeah, head is equal to new node. Yeah. Huh? Okay, so is the reversal clear to you? What is confusing? I mean, Kamar, are you clear with what we did here? I mean, when we were kind of doing the dry run. Okay. So now, yeah, Chirag, go ahead. So now you want me to repeat. Let me think what would be the probable doubt here. Right is equal to current dot next. So we are just making our. So what we are doing at this point is we want to secure the. You can say secure the linked list that is coming after current node, right? So let me just so for that we are doing this. Then actual link reversal is here, and then just this thing. Unable to understand how the address part of first node is becoming null. Address part of first node. This line only. At first, what is the value of prev? It's null, right? And I have initialized it that way, like knowingly, जानबूझ के किया है मैंने ऐसा, so that just by doing this line, that also works, right? So let me do one thing. Let me do a dry run for this one. Okay, we will return previous dot next. Oh, sorry. Yeah, return to किया नहीं मैंने. While logic is over, return previous, not dot next. If you carefully see, by the end of your logic, previous comes and stands here, right? So you don't need to return previous dot next. You can return previous only, right? So that's what you will do. Okay. Having said that, let's do a dry run for this question. Okay, let's take a small linked list. 1, 2, 3, and let's see if our code helps us in reversing this linked list or not. Okay, so Control C. Okay, this is there, है ना? Let me move our linked list somewhere else. Okay, 1, 2, 3. What do we have here? The first thing that we have here is current is equal to head. Okay, so current is pointing here. I'm just writing C, P and R. Okay, please understand. Current is equal to head, previous is equal to null. Okay, previous is equal to null. Right is nothing, it's just there. While current is not null, okay, current is not null. Right is equal to current dot next. So right just got assigned to this position. Current dot next is equal to previous. Current dot next is equal to previous, which is null at this point, right? And this link is gone because there is only one value that next can store, right? This is done, and now you're just moving it for the next iteration. Previous is equal to current, current is equal to right. So previous will come here, current will go here, and let me just get rid of the older representation. This is also gone. Is this part clear? I mean, it must be, right? Now what you are doing is you are just going to repeat the iteration, right? You are just going to come back to the while loop. While current is not null, let me just keep giving you the permission of, yeah, you can still chat, right? I mean, that permission is still there. Now what you're doing is current is not null. Okay, current is still not null, right? Right is equal to current dot next. So now you are moving your right to the next node, which is fine. Now current dot next is equal to previous. Current dot next is equal to previous. So this link is gone basically. The previous is equal to current. Previous is equal to current. Current is equal to right. Okay, so let's remove the older links. This is how the picture looks now. Okay, now for the next time, what do you have? Current is not null, is still not null. Right is equal to current dot next. So basically right will now go ahead and point to what? Null, because you are already at the last node. Current is at the last node, and dot next for the last node gives you null. So right is now pointing to a null. Basically right is not storing anything as of now, not storing any reference. So let me remove this link as well. Okay, so now what do you have here? Current dot next is equal to previous, right? Current dot next is equal to previous. So it's not pointing to null anymore. It's next is pointing to 2 now. And then what we have is previous is equal to current, current is equal to right. So previous will come here, and current will also go and point to null. So what do we have now? This is the older representation. What do we have now? We have a reverse linked list that looks something like this. Okay, if I try to draw the same thing in a different way, 3, 2, 1, and 1 is in turn pointing to null. So 1 is the last node, right? This is what you have there, and this is also pointing to null. So now if you come back here, current is not equal to null, current is actually equal to null. So you are done with your job. Return previous. If you return previous, you have returned the head of the reversed linked list. Is this clear to you now? Is it is a singly linked list reverse? हाँ, सब कुछ हम singly linked list पे करेंगे, right? WW हमने we have just studied it for theory purpose. It's nothing new, right? Doubly circular. It's just some sort of manipulation of the singly only. Can we take the int value of the node and update them at their reverse location? If yes, how? Can we do that? If yes, how? एक तरीका है, Vibhuti, that's coming to my mind. Store all the values of array of linked list in an array. Array reversal we know of an operation, right? We can do it on our own. Then traverse the linked list at the same time of traversal of the array. है ना? So then you can keep filling the values in reverse order, right? So Kamar, what's the doubt now? There's one doubt that I can take. You can unmute yourself.
हेलो सर
Yeah, go ahead.
ये सर लिस्ट रिवर्स कैसे हो रही है सर, ये मेरे समझ में नहीं आ रहा है
So
सर। ये सर
we are establishing reverse links, one link at a time. Okay. First हमने क्या किया, इसका link reverse कर दिया. Then we did it for this. Then we did it for this. Now the point is, how are we moving from one place to another? That's something that we can understand, right? So before we go there, one thing that we want to understand in general is, if this is how your linked list looks like, and this is the previous node, so this is the previous, this is the current node, and this is the next node. Now what you want to do is, you want to do something like this. This is what you want to do. If you do that, this will be gone, right? If you don't have a write, all this linked list will be gone. So basically this is something that we cannot do at all. Now coming back to what we have done to prevent it from happening, we have made a write variable.
सर फाइनली पॉइंट सर पॉइंटर को रिवर्स करना है सर,
Finally pointer को
रिवर्स करना है।
yeah, we have to reverse the links, right? So that's how we are doing it. This one reversed. Now this one is gone. So now what you want to do is, you want to do this also, you want to do this also. How will you do it? Just take your previous, current and write in the correct way, and you will be able to achieve it, because this is the previous now and this is the current now. So you want to have something like this, right? Logic तो आपने लिखा ही है ना, current dot next is equal to previous. So you just have to maintain these variables correctly, right?
Yes sir.
Is it necessary to take 3? Yes, Ishwar, it is necessary, because if you don't take care of the remaining linked list, it will be gone. You will lose reference to it. That's why we also need a third reference. ये तो हमें चाहिए ही है, current or previous, to establish this link. And we need a third reference, because if we don't maintain that, the linked list will be gone, right? Is it necessary to take 3 variables to do reverse linked list, or is there any other approach? No, it is necessary, right? If head is null, return head. That's a very good input from you, Mohit. But in our particular case, it will work like this. Because let's say head is null. Okay, Mohit, head is null, so current is equal to null, return previous. Previous is null only. By chance, that case is already working for us, so we don't need to worry about it. Okay, right? It was anyway supposed to get submitted, but you tell me if there is any doubt that you guys have. Code तो सही है ही. Reversal is something that you should be able to do in your sleep also. Some of you would not be clear with it as of now. I also was not clear with reversal, but I'm again telling you, there is only, I have already done the dry run, and both before and after writing the code. But you also go home after the class, you also try to do a dry run for this particular approach, right? Then only it will get clear to you. Okay. So having said that, we still have time. So there is one question that I think that will be discussed in your homework session, right? Adding 2 numbers. I am just discussing, you can say it's a younger brother. I'm just discussing the basic form of that question, right? We might not be able to complete it. That's not even in the agenda of the lecture. But yeah, let's try to see this question and try to solve it. So take input as a null, or if single element. What do you want to see, Kambar? Input as a null, this part I did not get. Single element, that is possible. Achha, okay. For reversing, take input as null. So it's in front of you, right? What do you want to do if you get an empty linked list? You want to return null. That's what is happening, right? Because when you will go inside the while loop, checking if current is not equal to null, but current which you equated to head is equal to null only. So what you will get here is return previous, whose initial value is null only. So that's not an issue. If you take one node, you should return that node only, right? Because even after reversal, that will remain the same. So what you will do here is write is equal to null, current dot next is equal to previous, which is already the case, and then you will do this, then you will return previous. So for that also it will be done in the same way, right? So let's talk about this particular question, right? Okay, a lot of you have already dropped, right? We started with 280, 290 something, and now 100 people have dropped, but doesn't matter, right? So you are given two non-empty linked lists representing two non-negative integers. ठीक है? Two linked lists are there. They are representing numbers. Okay. The digits are stored in the reverse order. That's one important input, right? Each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. Okay, so what they are saying is 243. This number that you see here, it's not 243. First of all, it's 342 because the numbers are stored in reverse. And similarly, it's 465. So how you will add it is, you will first add these two numbers, because आप add कैसे करते हो? You add from the back side, right? But here, because the number is reversed, you can straightforward, you can add it from here, right? So you add it, you get 7. You add it, you get 10. But how do you write like 10 in an addition? 0, and you send 1 to the carry, right? 3 and 4 you add, you get 7, and you also add the 1 that you got from carry, and you write a 8 here. So that's what you are supposed to do. That's the problem statement. So is the question clear to you, first of all, before we try to go for the solution, right? Question is clear, right? The point here is numbers are written in reverse. So that way it is becoming easier for us to do this carry, right? So now let's see, about how we can tackle this particular case. There is one thing that I want to basically point out at before we begin this question, right? This is a simple, straightforward example, right? So there are 2-3 things that must already be coming to your mind. For each time when we are considering the sum, we will also have to take into account the carry that is coming from the previous iteration. Also, what we need to take care of is, what if you have a case like this? Let's say you are adding 41. So let's say 1, 4 and 65. Right, so it's like you will have a 6 here, that's fine, but you will have a 0 here. Sorry, you will have a 0 here. So my point that I want to explain to you is, this is your answer, right? If you add 41 and 65, your answer is 106. So your answer will be 601. So my point is, you will have to add one node, right? So basically, do you see, this is happening only because of carry. So I just wanted to tell you how important the use of carry is going to be in this particular question, right? And like how you want to move forward is, so you want to take the sum, right? You want to store it in a node, and then what you want to do is, you want to keep doing it. You want to keep doing it iteratively, right? Store this sum, then take this sum, store it somewhere, and do this thing, right? So are you getting the picture that we want to do something like this? Inserting at the end, right? Inserting at the end. So we will have a temp kind of iterator that we will keep moving in each iteration, right? That we will keep moving at each iteration. Maybe it's going to tell you points the end of the linked list. So basically, you can directly use the temp variable to add the new node to the linked list. So I'm just throwing around some hints for you guys to pick the question up and start solving it. So I'm not formally discussing the approach now. So are you guys getting an intuition on how we will do it? And then we will discuss one problem that is actually there. After loop, if carry is greater than 1, insert 1. Yeah, Mohit, definitely. You got it. That's what I meant. We will have to create an extra new node. Yeah. This time we will have to create new node. 25 plus 85 will also give 3 last digit. Yeah. 25 plus 85 will not 3. It will give 1 only, Vibhuti. But yeah, I get your point. we will have 3 nodes. Maintain the previous node to add the node to the right. We will have to have access to the previous node, or you can say the node that we have just added, so that the newly created node that we want to add, we can add it after that, right? Both linked lists will have same size of node or not. No, Vibhuti, no condition like that. You can say one number is 10, another number is 1000. So it will look like this, right? 0, 0, 0, 1, and another number will look like this, 0, 1, right? So that's how it will be. Please tell both time complexity and space complexity after code. अभी तक की तो क्लियर है ना? अभी तक अपन ने जो किया है, रिवर्स में O of n है, ये भी O of, ये तो O of 1 है, ये क्या था? डबल लिंक लिस्ट ना, O of 1, and insertion in circular linked list. This also, because of the way we have done it using last, it's O of 1 only. But yeah, let's come back to this, right? Yes, Amar, any doubt? Yeah, go ahead.
हेलो सर, आई एम ऑडिबल?
हाँ या
सर, मेरे को 2-3 प्रॉब्लम्स आ रही हैं सर। कल से मैं उसको चाहता था पूछ नहीं पा रहा था।
बोलो।
एक पहली प्रॉब्लम सर ये, जो आप सर क्वेश्चन करते हैं, वो जो आपके पास पोर्टल है इंटेलिजेट, उसमें सर आप तीन वो बनाते हैं, मतलब कि एक जावा बनाते हैं, वो सॉरी एक नोड बनाते हैं, एक मेन बनाते हैं। तो हम इसको मतलब फॉर एग्जांपल किसी दूसरे प्लेटफॉर्म पर मतलब सेट बाय सेट करके लिख सकते हैं, ऊपर नीचे करके।
मैंने बताया था आपको फर्स्ट क्लास में, यू कैन डू इट। ओके, जब मैं आपको बताया था कि ये क्लास नोड वाला पोर्शन उठा लो, डोंट इंक्लूड पब्लिक। ओके, क्लास नोड वाला पोर्शन उठा लो, राइट?
सर व्हाई डोंट इंक्लूड पब्लिक?
हाँ
सर, पब्लिक यहाँ पे क्यों इंक्लूड नहीं करना सर, जैसे अभी आपने कहा?
सो बेसिकली द लॉजिक इज इन वन जावा फाइल देयर कैन ओनली बी वन पब्लिक क्लास, सो दैट्स व्हाई आई एम सेइंग अपने को वी आर नॉट we are not using the access modification anywhere, so let's just drop it all together, है ना?
Okay. Okay. और सर दूसरी सर प्रॉब्लम ये आती है, आज आपने यहाँ लिखा पैकेज मॉड्यूल टू सितंबर डॉट लिंक लिस्ट। हम सर यहाँ पे जब फॉर एग्जांपल जीडीबी पर कॉपी पेस्ट करें तो हम वहाँ पर क्या लिखें सर?
फिर से
अच्छा, आपने सर पैकेज लिखा है,
include this ना, this is my computer's module setting।
सर वहाँ पर हम मेन लिख सकते हैं ना, मेन?
सॉरी, कम अगेन
सर। हम जब इसको जीडीपी पे कॉपी पेस्ट कर रहे हैं तो वहाँ पर मेन लिख सकते हैं ना, इसके मॉड्यूल टू सेट इसके जगह पर पैकेज जो
पूरा सिर्फ क्लास मेन से शुरू करो।
और सर एक प्रॉब्लम सर ये आती है, जैसे कि अभी आपने कोड कराया है लीड कोड पर, 2-3 आपने क्वेश्चन कराए हैं उसको।
हाँ,
अगर हम इसको लीड कोड से उठा के हम अपने नॉर्मल जीडीपी पर रन कराएं तो हम उसमें अकॉर्डिंगली क्या क्या चेंज करेंगे? जैसे सर लीड कोड पर आपने एक क्वेश्चन खोल लगाए, आपसे तो ऊपर लिखा डेफिनेशन फॉर सिंगल लिंक लिस्ट, उसके नीचे आपने पब्लिक की क्लास लिखी है, उसके बाद इंट वैल्यू लिखा है, फिर लिस्ट नोड नेक्स्ट।
ये सब लिंक लिस्ट का कोड यू विल नॉट बी एबल टू रन इन योर जीडीबी।
नहीं सर, मैं सर रन करने की बात नहीं कर रहा हूँ, एज इट इज मैं कह रहा हूँ उसमें हम क्या क्या चेंज करें कि हम जीडीपी पर रन हो जाए। फॉर एग्जांपल जैसे आपने यहाँ क्लास सॉल्यूशन लिखा, वहाँ पे हम क्लास सॉल्यूशन नहीं लिखेंगे।
अभी तो बोला ना कि मैं रन करने की बात नहीं कर रहा हूँ, फिर तुम बोलो कि मैं जीडीपी पे रन कैसे करूँ? जीडीपी पे रन नहीं होगा
सर, जीडीपी पे नहीं। ये हम जो हमारे लीड कोड का जो कोड है, जैसे आपने यहाँ लॉजिक लिखी है सर, लॉजिक तो सेम रहेगी ना सर?
हाँ,
हमारे यहाँ पर लीड कोड पर मेन फंक्शन नहीं लिखा हुआ है और नोड का जो फंक्शन है वो नहीं लिखा हुआ, वो हाइड है। तो सर हम ये दो फंक्शन अगर हम जीडीपी पर लिखें और ये लॉजिक लिखें जो यहाँ पर फंक्शन लिखा हुआ है, तब तो रन करेगा ना सर?
ओके, हाँ, सो यू कैन यूज इट इन व्हिचएवर वे यू वांट टू। जैसे क्लास सॉल्यूशन है, उसमें आपकी क्लास मेन के अंदर ही आप ये कोड डाल दो, राइट?
क्लास मेन के अंदर ये कोड डाल देना सर, और वो जो नोड की क्लास बनती है वो भी तो बनानी पड़ेगी ना हमको।
हाँ, वो सब तो बनाना ही है। हाँ,
तो सर ये रन कर जाएगा?
यस, इट विल।
सर क्या आप कोई सर ये जो आप ये क्वेश्चन कर रहे हैं सर, ये इसको हम जीडीबी में कर सकते हैं सर? एक कोड कर दीजिए।
You can ask your doubt instructor to do that, right? So that way both the things will be done, right? I mean,
okay.
GDP पे भी हो जाएगा और बस GDP पे करना होगा।
GDP पे, हाँ GDP पे हो या हमारा जो पोर्टल है एक्टिव पोर्टल है उस पर रन हो जाए, दोनों पे किसी पे भी रन हो जाए।
This one we have anyways done, right? ये तो अपन ने देख लिया from scratch।
ये सब देख लिया।
Now this is similar to GDP only। ये तो पूरा कोड है, right?
हाँ, yes.
As it is Control C Control V you can do, And so take reference from this. No, see what I've done here. Public class main is there, but I have just made 2 classes outside of it.
एक class node और class link लिख दो.
Your GDB code is going to look like this only, right? Okay. Anyways, coming back to the discussion. Sure, Sama. Coming back to the discussion that we were having. Okay, so this is how we want to do it, right? Each time the sum that we are adding, we want to include it at the end of the linked list that we are creating, right? There is one small problem, however. Okay, first up dekho, try to think about it. You want to add the current node, ये जो भी आपने sum बनाया है, you want to add it next to the previous node, right? What will you do when you are adding for the first time? Do you identify that problem? So basically I am saying, if you have a scenario like this, 1 5 then 5 5, so what you will do is, what I am saying is, यहाँ पे आपने एक बार 6 कर लिया, so next time what you will do is, this summation that you are doing, you are getting a 0, this new node that you are creating, you will add it after 6. Okay, then you will add 1 after 0. All that stuff you will keep doing. Okay, so for 0 this will be your temp, for 1 this will be your temp, this way we will do something like temp.next is equal to new node, whatever. But how will you add this particular node? How will you take this into consideration? There is nothing to support it here, right? There is nothing to support it here, right? So there's a very simple proposal that I have for you. Tell me if you understand it or not. Let's create a dummy node. Okay, let's create a dummy node whose job is only to support that when I'm inserting this particular node, it's going to accept this. So my dummy node is going to my temp initially. So my temp is initially going to point to my dummy node. As soon as I make my first actual node, I will add it next to temp. Then I will keep doing this in iterative fashion. Ultimately what I will have is, I will have a dummy node and then I will have my answer like this, right? So what I will simply say is, I want to return from this particular point, so you can say return dummy.next, right? Is this logic getting clearer to you? Okay, here I want more yeses because this is something I'm introducing for the first time. I tried to do it last time but dropped the idea because you were having doubts. But yeah, so Vibhuti, can you please basically tell me your concern? Yeah, Pranchu, go ahead.
सर ये डमी आपने जो बनाया है सर, ये नहीं समझ में आया, डमी की जरूरत क्यों पड़ेगी हमें?
क्यों पड़ी, राइट? तो देखो, so what I'm doing is, I'm doing something like this. At each point I am storing the sum in some newly created node, and what I want to do is, because of the fact that my numbers are opposite, reversed, हम लोग number ऐसे, if I want to add 15 and let's say 18, I will add from here only, from the reverse.
Yes, sir.
So now that my numbers are already in reverse, I can start adding it from the front, first point. Yes, so yes, that way the construction of linked list is getting easier, क्योंकि यहाँ पे ही sum करके इसको जोड़ दिया, then यहाँ का sum करके इसको यहाँ पे जोड़ दिया, right?
Yes, sir.
We're adding it there. Now the point is, once you have 6, your first node, after that adding 0 is very easy. All you will have to do is temp.next is equal to new node, whatever, right? Yes, and yes, you can just keep doing, then you can after that you can add temp is equal to n, because now yes, when you want to add the next node that will be created in the next iteration, for that you are updating the value of temp, something like this.
Yes, sir.
My point is, what will you do for the first time? Because temp will be something yes, like temp
start
yeah, only for the starting, only for beginning it, I am doing it like this. Otherwise, yes, समझा?
Yes, yes, समझ.
Otherwise क्या करना पड़ता? Otherwise, what you would have to do is, you will have to So you're writing an iterative code, right? Let's say 10 lines of logic iteratively. That is repeating, giving you the final answer. You will have to write this 10-line logic outside while loop also once.
Yes.
For doing the first run, है ना?
Yes. Initiate.
सिर्फ head निकाल पाते.
Yes.
But to make it generalized, what I am doing is I am saying that temp is at some dummy position.
Yes.
Temp is standing somewhere, and then you are adding it in a generic way, right? Then you are adding it in a generic way, and ultimately what you are doing is this is dummy, but you know that just from the next node itself, you are having, you can say, informative nodes, right? That are actually going to make sense.
तो मतलब हम टेम्प इनिशिएट वो डमी इनिशिएट करने के लिए बना रहे हैं, टेम्प को इनिशिएट करने के लिए डमी का क्रिएशन करना है ताकि हम इनिशिएट कर सकें पहली बार.
So that when we are creating the first node, we have some, we have some position to insert it to.
Yes.
Inserting at first in loop and inserting at last after loop. I'm not getting this statement, Mohit. We are inserting at last only. We are creating the node, inserting it at the last only. If we don't use dummy node, then we will lose all the elements. Mohammed, not only that, if we do not use dummy, we will have to separately write the code for creating the head first, and then only we will be able to come inside the while loop and do all that stuff. But we need to return the reverse list. No. जो ये आ गया वो return कर देना है. No one is asking you to return it. 708 answer है. Right? Actual answer is 807, but you are returning 708 only. Right? So this question, don't worry, this question will be discussed from scratch in your doubt class. I am just taking it just to give you a brief understanding, right? Can we initialize head first and then we go to the while loop? Yes, you can do it, but that will be the number of lines of code will be double. पहले आपको एक iteration पूरा चलाना पड़ेगा, बस head मिलेगा उसमें. फिर you will be able to generalize it, right? So basically, I am telling you to do it with the help of dummy. You attempt it without dummy, right? You will have to create head first. So देखना आपको पूरा process repeat करना है head केवल head बनाने के लिए. That doesn't make sense, right? In that question, if our linked list is like not getting your question, Vikram. Okay, anyways, this is okay. So now the question is, I have talked about how we are going to insert, but we have not talked about how we are going to consider the sum, right? So we're having two linked lists, right? L1, L2, like that. So first thing is I want to declare a carry variable is equal to 0, right? Then we have list L1 and L2. So see, this can happen that your one list has ended and second list is still there. So for the case of 1000 and 100, right, you will have something like this, 100, and you have 10 here, right? So when you will add, you will have something like this, 0, 1, 1, something like this, right? So basically my point is, in this particular scenario, you want to keep moving till the time any of the linked list is alive. So either list 1 dot or list 1 not equal to null, or list 2 not equal to null. If either of these scenarios are there, you will just keep going. Okay, so I'm writing a particular snippet of code. Tell me if you are comfortable with it, right? While here I will write that logic, but I'm skipping that part. If L1 is not equal to null, because it's also possible that list 1 puri end ho chuki hai, so we don't need to consider any number from there, right? So what I mean to say is, when I will add the sum for this position, I will not have any participation from the list 2, right? So that's why I'm saying, if list 1 is null, or let's say list 2 is null, that means I've covered all the numbers of list 2. I don't need to add any number from list 2 anymore, right? So that's what I'm saying. If list 1 is not equal to null, in that case, so let's also declare a sum variable, right? Sum is equal to 0 kar lete hain. Sum, sum is equal to 0 से यहाँ से start करते हैं. Sum plus is equal to list 1 dot val, right? And list 1 is equal to list 1 dot next for the further rounds, right? दूसरी condition क्या है? Same for L2. What you will do is sum plus is equal to L2 dot val, L2 is equal to L2 dot next, right? And now what you are doing is sum plus is equal to carry, whatever carry you got, right? So this is the final sum. Now let's say the sum that you got is 17. So the value that you want to store inside the node will be 7 only, right? So I'm going to tell you something now. Carry is going to be what? Carry is going to be sum mod 10, because if let's say 17 is there, right? If 17 is there, sorry, carry is going to be sum by 10. If 17 is there, you will send 1 to carry, that is 17 by 10, and sum will become equal to sum mod 10. Because if you're having 17 as a particular sum at a particular time, you only want to store 7. You want to send 1 as the carry, right? So this is what you will have. Now create a new node. List node n is equal to new node, new list node, right? What is the value you will send? You will send the value of sum, and what you will do here is temp dot next is equal to n, temp is equal to n. Okay, so let me also do that dummy calculation that I was telling you about. Is equal to new list node is equal to dummy, right? While if either of the list is alive, you will just keep doing this. If L1 is not equal to null, or if L2 is not equal to null, that means you will only go out of the while loop if both the lists are over, right? Are you getting some sense out of it? So my point is not to tell you the whole question today. I just wanted to give you a hint, but since you are clear with that, I went ahead to code about it. But are you getting clear about it? Would both the linked list always have Gaurang, no. Right? L1 and L2 are head values. Yeah. L1, L2 are head values, Vibhuti. At the beginning, we are getting the head value only. Okay. So what you will do here is, if carry is greater than or equal to 1, you will make a new node, list node. You can say n is equal to new list node, right? And then what you will have is, let's send the value carry here, right? And then what you can do is temp dot next is equal to n. That's it. Return dummy dot next. So let's see if it works or not. Right? I also coded this question after a long time. This is an interesting question. Got accepted, but yeah, it will anyways get accepted, right? Because like we have done it correctly. But the most important thing is you telling me if it's clear or not, right? Because if you have doubts, you can ask it. This is the bonus question. This we didn't even intend to solve it here. Time complexity, if you ask me, it's going to be order of length of the bigger linked list. Okay. Who asked it? Vikas, है ना? Tomorrow's agenda. So Sadan, tomorrow I am not available. So, and we were actually planning this as well. So because today we had a longer, you can say, lecture session. Tomorrow we will have only doubt session, only for questions. So treat tomorrow as a break, okay, where you get the opportunity of solving questions. You will not be thrown with any new theory like doubly linked list or circular linked list, anything. So what I would advise you to do is relax and कल contest है क्या? I am not aware of that. Relax and do a dry run for all the codes that you find problematic. आपको लिंक लिस्ट इंसर्ट करना नहीं आ रहा है, आपको लिंक लिस्ट क्रिएट करना नहीं आ रहा है, टेक tomorrow's time and do that. Okay, come to the doubt class. You will have a bigger doubt class tomorrow, longer duration doubt class. Come to the doubt class and ask your doubts there, right? For example, asking them to solve on GDB or wherever, right? Solution session have access for this question. Please show us their approach. Solution session have access for this question. समझा नहीं मैं. ना जय you can't return list 2. भाई हम लोग इतनी मेहनत से we are trying to make a new linked list, right? Why do you want to return list 2 randomly, right? List 2 will be just some random set of numbers. Okay. Yeah, so just a second, right? Linked list. So Anant, to answer your question, we were done with linked lists the day we started it, right? Because even today for this question also, did I tell you some new theory? No, right? Initialize 2 times. Why? Where? Sum I am adding because what will sum contain? Sum will contain this plus some carry. So first value plus second value plus if there is some carry, right? So I'm starting sum from 0 and then I'm doing that. Acha, solution tab here. Why am I not able to? Elementary math. Keep track of carry using variable this head of this. एक ही अप्रोच है तो वही वाली होगी. इसने उसी को थोड़ा सा कॉम्पैक्ट कर दिया है. x is equal to this, y is equal to this, carry plus x plus y, carry is equal to sum by 10. वही कर रहा है. Same thing. Exact same thing. Okay, let me try to repeat the whole thing once again in a fast manner. Okay, even if you don't get it, do not worry, but if you get it, it's very, very good. Okay, because this question is not of the easy type, right? It's as they mentioned, it's a medium question only, right? Okay, so first thing that I want to tell you is about the dummy node. I have created a dummy node. Okay, just as of now, don't try to ask why I have created it. I told you, but because we have less time, don't think about that. Just think that because we have it, can we are we able to understand the code with dummy in it? Okay, just focus on it in that way. Don't think about the why of dummy at this point. Now, in this line, all I am doing is I am just trying to get the correct value for sum. It's like 2 plus 5 plus if there is any carry. If there is no carry, so see the default value for carry is 0 only, right? Then what I am saying is sum plus is equal to carry. So now I have the correct value in sum. But what you need to understand here is from these two lines, see, carry will be sum by 10. If the sum is 17, if I add the numbers 8 and 9, the sum will come out to be 17. All of you know from mathematics, you will store 7 there and you will send 1 at the carry, right? So that's why, what are you sending at the carry? Sum by 10, right? And what is the sum that you are storing? Sum mod 10. That is the remainder when you divide by 10, right? Now you are creating a new list node to take that sum into account. So new list node taken, and now you are adding this newly created node to the end of your linked list that you are making for your answer, that you are storing your answer in, right? So what you are doing there is temp.next is equal to n and temp is equal to n, because now for the next new node that you will create, this particular node that you have just inserted will act as the previous node, right? So I hope it is at least some clarity you got. And even after considering both the linked lists completely, you still have to check if carry is greater than or equal to 1. Because if carry is still present, you have to make one last node to take care of that carry, right? To understand this line, a very easy example is to add 10 and 90. Okay, do that addition and it will become very clear to you, right? Why do we need line 33? I think you're talking about this line, right? So I told you, right? After adding, after doing the addition for the last time, it is possible कि आपकी दोनों linked list खत्म हो गई हैं, right? Both L1 and L2 are null. But still, what you're having is you're having some non-zero carry value, right? You're having some non-zero carry value. It's you can also look at it this way, greater than 0. So if you have some non-zero carry value, you only are supposed to put it somewhere in the number, right? उसको आपको कहीं पे रखना पड़ेगा, right? That non-zero carry value. So for that you will create a new linked list, new linked node, or you can say list node, and store that carry value there. See, I have stored the carry value there. And same thing कर दी, temp.next is equal to n कर दिया, right? सर एक बार लूप से पर्टिकुलर इंडेक्स पर कोई एलिमेंट डिलीट करने का ओनली फंक्शन बनाकर एक्सप्लेन कर दीजिए. Yeah, people, that you can do yourself actually. एक बार लूप से, right, for some particular index if you want to delete. If you want to delete the third element, just keep moving your iterator 3 times. That's all you need to do, right? Okay, cool then. I think now we can put a break